The most dangerous idea in modern science is not that the universe is expanding, it is that most of it is empty. Between every star you have ever seen, between every galaxy you have ever imagined, there is an ocean so vast that light itself can travel for millions of years without touching anything we would call matter. We name this ocean space, and we comfort ourselves by calling it empty, as if emptiness were harmless, as if nothing could happen there. But emptiness is only a word, and words are often how we hide from what we do not understand. Close your eyes for a moment and picture the night sky. Not the stars, not the constellations, not the glowing bands of the Milky Way. Let those fade. What remains is not darkness, but distance. An immeasurable distance where, according to everyday intuition, nothing should exist at all. Yet, physics has never been comfortable with the idea of nothing. In the language of classical thought, empty space was a background, a silent stage where matter performed and time passed. Space itself was passive, inert, indifferent. If there were no particles, no radiation, no energy, then there was simply nothing happening. That belief survived for centuries because it felt reasonable. We experience emptiness every day. An empty room, an empty cup, an empty stretch of road at night. Emptiness feels like absence, and absence feels safe. But the universe does not use human intuition as a design principle. When physicists began probing the smallest scales of reality, the idea of emptiness started to fracture. Not dramatically at first, quietly, like a hairline crack spreading through glass. They discovered that even when every particle is removed, when temperature is lowered as close as possible to absolute zero, when radiation is stripped away and matter is gone, something stubborn remains. Energy. Not energy in the way a battery holds it or a star burns it. A subtler form. A restless, irreducible hum that cannot be eliminated, only minimized. This is what we now call the quantum vacuum. The word vacuum suggests suction, hollowness, a void. But the quantum vacuum is none of those things. It is the lowest possible energy state of reality, and it is anything but still. Within this so-called emptiness, fluctuations occur. Tiny, spontaneous changes in energy appear and vanish too quickly to be directly observed. They leave no tracks, no lasting traces, no photographs. Physicists call the entities involved virtual particles, not because they are imaginary, but because they exist on borrowed time. They emerge, they interact, they disappear, all within intervals so brief that the universe barely has time to notice itself doing it. This is not speculation. These fluctuations produce measurable effects, forces that should not exist if space were truly empty, pressures that arise between objects placed close together, as if the nothingness between them were pushing back. Empty space, it turns out, has structure, and structure implies activity. At this point, many people feel a sense of relief. The mystery seems contained. Emptiness is not empty because physics says so. There are equations, there are models, there are names. The discomfort fades as knowledge fills the gap. But this is where the more unsettling question begins to form. If empty space is not empty, then what exactly is it doing when nothing appears to be happening? For most of the universe's lifetime, nothing dramatic occurs between stars. No explosions, no collisions, no radiation storms, just long stretches of apparent stillness. Millions of years pass without any visible event. Civilizations could rise and fall on planets without that space ever seeming to change. And yet, at the quantum level, it never stops moving. The fluctuations do not pause, the fields do not rest, the vacuum does not sleep. It is active even when there is nothing to react to. This creates a quiet conflict at the heart of our understanding. Activity without events, energy without fuel, change without direction. We tend to associate motion with intention and interaction with purpose. When something moves, we assume there is a reason. When something responds, we assume there is an observer. But the vacuum responds even when there is no one watching, or perhaps, especially then. This idea makes you pause. If something about the word empty no longer feels as comforting as it did a few minutes ago, I invite you to support this quiet exploration. Please like this video, share it with someone who enjoys deep, unspoken questions, and subscribe to Whispers of the Universe. This channel exists to explore the spaces most people overlook. Now, let us drift a little deeper. Imagine the vacuum not as a void, but as an invisible ocean. No surface, no waves you can see, no shoreline, only a continuous medium stretching through everything. Stars float in it, galaxies drift through it. Even your body, at this very moment, is immersed in it. You are not surrounded by emptiness. You are embedded within it. In an ocean, waves can exist without a single observer. Currents can move without purpose. Pressure can build without intention. The ocean does not need to know it is an ocean to behave like one. The quantum vacuum behaves in a similar way. It does not require matter to justify its existence. It does not wait for particles to arrive before becoming active. Its fluctuations are not reactions. They are conditions. This distinction matters. A reaction implies something happened first. A condition simply exists. When we remove all matter from a region of space, we are not creating nothing. We are revealing a condition that was always there, hidden beneath the noise of particles and radiation. And conditions shape outcomes. This raises a question that physics does not ask directly, but cannot fully avoid. If the vacuum is a condition that permeates all of space, and if it is active even in the absence of events, then could it influence what happens when events finally do occur? Not by choice, not by intention, but by presence. A microphone does not decide what to record, yet it shapes the sound it captures. A lens does not choose what to distort, yet it bends light all the same. A background does not act, but it frames every action that takes place within it. What if empty space is not a background at all? What if it is the quiet framework that every interaction must pass through, be filtered by, and subtly altered within? At first, this idea feels abstract, even harmless. But as it settles, it begins to erode a deeper assumption, that observation is something only conscious beings do. In physics, observation does not require awareness. It requires interaction. When a system interacts with another system, information is exchanged, states are altered, possibilities collapse into outcomes. By that definition, the vacuum is constantly interacting with everything. Particles do not move through empty space as if through nothing. They move through a sea of fields. Their properties are shaped by that sea. Their behavior is constrained by fluctuations they did not create and cannot avoid. Even light is not immune. As it travels through the vacuum, it is influenced by the underlying structure of space itself. Not enough to notice easily, not enough to see with the naked eye, but enough to matter. The universe, it seems, is never truly alone with itself. This is where language begins to fail us again. We want to ask whether the vacuum knows anything, whether it observes anything. But these words carry too much human meaning. They suggest intention, awareness, curiosity. The vacuum has none of these. And yet, it still participates. It still responds. It still constrains. It still records interactions in the only way physics knows how, by altering future possibilities. This is not a claim. It is an implication. If the vacuum were truly nothing, it would do nothing. But it does something, constantly, everywhere. And if that is true, then the emptiest regions of space may not be the most inert parts of the universe. They may be the most fundamental. We have spent centuries looking at stars because they shine. We have built telescopes to capture light because light is visible. We have listened for signals because signals announce themselves. But the space between those signals has been quietly shaping the universe all along. Not loudly, not dramatically, but persistently. As we move forward, we will begin to question whether empty is even the right word to use anymore, whether absence is truly absent, whether the vast dark between the stars is merely waiting or quietly doing something else entirely. For now, let that thought rest without resolution. The space between stars is not silent. It is simply speaking in a language we have only just begun to hear. We use the word empty as if it were precise, as if it described something real. An empty room, an empty street, an empty sky. In daily life, emptiness feels familiar. It means absence. It means nothing is there to demand attention, nothing to respond to, nothing that can surprise us. Emptiness feels like relief, but this comfort comes from language, not from reality. Because empty does not mean the same thing in physics as it does in the human mind. When you say a glass is empty, you mean it contains no water, but it still contains air. And even if you remove the air, it still contains heat, electromagnetic fields, and the constant vibration of atoms in the glass itself. Empty is always relative. It only means empty of something specific. In everyday thinking, we quietly skip that distinction. We treat empty as absolute, as a final state, as the end of content. Physics never does. In physics, empty space is not defined by what it lacks, but by what remains when everything removable has been removed. It is a boundary condition, not a void, a baseline, not a blank. This difference seems subtle, almost pedantic, until you realize how deeply it shapes our intuition about the universe. For centuries, scientists imagined space as a neutral container. Matter existed in space. Events happened within space. Space itself did nothing. It waited. This idea was so powerful because it mirrored how the human mind experiences the world. We notice objects, we notice motion, we notice change. The background fades away. Walls disappear when nothing moves against them. Silence feels like the absence of sound, not a presence of its own. So when early science described space as empty, it was not laziness. It was honesty, filtered through human perception. But perception has limits. The problem begins when we mistake those limits for truth. As instruments became more sensitive and theories more precise, physicists discovered something unsettling. Removing matter from space did not remove activity. Cooling a region of space did not silence it. Eliminating radiation did not calm it. Something remained, always. Not something you could point to, not something you could isolate, but something that refused to vanish. This forced a quiet shift in meaning. Empty space, in physics, does not mean nothing is happening. It's coast. It means nothing familiar is happening. To encross. And familiarity is a dangerous filter. We assume that what we cannot see is inert, that what we cannot touch is passive, that what does not announce itself is irrelevant. But the universe has never respected those assumptions. At the quantum level, the idea of emptiness collapses almost immediately. Fields exist everywhere, whether or not particles are present. These fields are not optional layers added on top of reality. They are reality's foundation. Particles, in this view, are not little objects moving through space. They are excitations of fields, ripples, temporary concentrations of something that is otherwise spread everywhere. Remove the ripples, and the ocean remains. This is where the word empty begins to fail completely, because an ocean without waves is not empty. It is calm, and calm is not the same as nothing. The quantum vacuum is often described as the lowest energy state of a field. This sounds technical, abstract, reassuring, but it hides a deeper truth. Even the lowest energy state is not zero. There is no off switch for reality. Energy cannot be fully drained away. Motion cannot be completely halted. Change cannot be entirely prevented. There is always a residual activity, a baseline fluctuation that persists regardless of conditions. This means that emptiness, in the physical sense, is a dynamic state. It is alive with potential, even when nothing seems to occur. Here is where the mind naturally pushes back. If nothing observable happens, how can anything be happening at all? If particles appear and vanish too quickly to be measured, do they truly exist? If energy fluctuates without consequence, does it matter? These questions feel reasonable. They feel grounded, reflect a deep-seated belief that existence requires persistence. But quantum physics does not agree. At the smallest scales, existence does not need duration. It does not need stability. It does not need to leave a mark. It only needs permission from the rules of reality. And the rules allow brief, silent, transient events to occur everywhere, all the time. This introduces a strange inversion. In classical thinking, emptiness is the absence of events. In quantum thinking, emptiness is the absence of stable events. Instability becomes the norm. Permanence becomes the exception. This is a difficult idea to live with because it erodes a comforting boundary. We want emptiness to be safe, predictable, neutral. We want it to be a place where nothing can reach us. But physics does not grant that safety. The space between stars is not a buffer zone. It is not a pause between meaningful things. It is a continuous medium where activity never truly stops. Even when no particle passes through, the fields remain. Even when no radiation flows, the energy fluctuates. Even when nothing interacts, the conditions persist. The universe does not turn off when nothing is happening. It simply shifts into a mode we are not evolved to notice. This realization produces a subtle but powerful discomfort. Not fear, not panic, just unease. Because it suggests that emptiness is not the opposite of presence. It is a different kind of presence. And presence implies influence. If empty space has structure, if it has energy, if it has rules that shape what can and cannot occur, then it is not a passive backdrop. It is an active participant in every event that unfolds within it. Stars form inside it. Light travels through it. Time progresses alongside it. Nothing escapes it. This does not mean space has intention. It does not think. It does not plan. It does not watch in the human sense. But it does something more fundamental. It constrains. Every particle's behavior is shaped by the properties of the vacuum it moves through. Every interaction is filtered by the underlying fields that fill space. Even the constants of nature, mass, charge, speed, emerge from how these fields behave in what we casually call nothing and for day. This shifts the question again. If empty space is not empty, and if it actively shapes reality, then calling it a void is not just inaccurate, it is misleading. A void suggests absence. But what we are dealing with is a presence without form, and presences without form are the hardest to notice. Human cognition is built to track objects. We are excellent at recognizing shapes, edges, boundaries. We are terrible at perceiving continuous fields. We ignore air until it moves violently. We ignore gravity until it fails. We ignore silence until it breaks. Space, it seems, has survived our attention by never demanding it. But this invisibility should not be mistaken for insignificance. When you strip the universe down to its bare minimum, when you remove everything that can be removed, what remains is not nothingness. It is a condition, a restless baseline, a subtle, ever-present activity that does not need matter to justify its existence. This condition existed before the first star formed. It existed before the first atom cooled. It existed before light had anything to illuminate. In a sense, emptiness came first. And that inversion is deeply unsettling. because we are used to thinking of emptiness as what is left behind after things are gone, not as the foundation upon which things appear. If the universe began in a hot, dense state, it still expanded into something, a structure that could stretch, vibrate, and support fields. That something was never empty in the way we imagine emptiness. It was simply unfamiliar, and unfamiliarity, when stretched across cosmic scales, becomes mystery. As we move forward, we will need to let go of the comforting idea that empty space is passive, neutral, or inert. We will need to treat it as an active environment, not alive, not conscious, but undeniably involved. The space between stars is not waiting for something to happen. It is already happening, quietly, relentlessly, without witnesses. And once you accept that, another question begins to emerge, almost against your will. Empty space is always active, always fluctuating, always shaping what can occur. Then what happens when something finally does interact with it? What does emptiness do when it is disturbed? That question does not end here. It drifts forward, carried by the same invisible ocean we are only beginning to sense. At first, the idea feels almost manageable. Empty space is not empty. It contains energy. It fluctuates. So far, this sounds like a technical correction, not a philosophical threat, a refinement of language, a footnote added to an old definition. Many people stop here, satisfied that the mystery has been addressed. But this is only the surface. Because the moment we accept that empty space contains energy, we are forced to confront a question that physics did not intend to ask, but cannot avoid. Where does that energy come from? In every other context, energy has a source. A battery stores it. A star generates it. A collision releases it. Energy moves from one form to another, but it does not appear without reason. Except here. The quantum vacuum has energy even when there is nothing to supply it. No fuel, no particles, no radiation, no heat. And yet, measurements insist that it is not zero. This is not a loophole. It is a rule. At the heart of quantum mechanics lies a principle so simple it feels almost innocent. You cannot know everything at once. Certain pairs of properties, like position and momentum, resist being pinned down simultaneously. The more precisely one is defined, the more uncertain the other becomes. This uncertainty is not a flaw in measurement. It is not a technological limitation. It is woven into reality itself. And when this principle is applied to energy and time, something remarkable happens. Energy cannot remain perfectly fixed, even for a moment. If a system exists for any finite amount of time, its energy must fluctuate, not because it wants to, not because something disturbs it, but because perfect stillness is forbidden. The vacuum exists in time. Therefore, its energy cannot be perfectly stable. This means that even the lowest possible energy state of space must ripple. It must jitter. It must briefly borrow energy and then give it back. These brief borrowings give rise to what physicists call virtual particles. The name is misleading. Virtual does not mean imaginary. It means transient. These particles do not appear in detectors as stable objects. They cannot be isolated or captured. They flicker into existence and vanish before they can be directly observed. But they are not meaningless. They interact. They exert forces. They alter outcomes. The universe behaves differently because they exist. This is where the idea of emptiness begins to crack open. In classical thinking, existence is binary. Something either exists or it does not. If it exists, it persists long enough to be seen. If it cannot be seen, it might as well not exist. Quantum reality does not respect this distinction. Existence becomes probabilistic, temporary, conditional. A particle can exist briefly, influence its surroundings, and disappear without ever becoming real in the everyday sense. And yet, its influence remains measurable. This is deeply uncomfortable for the human mind. We are built to trust persistence. We believe in things that stay, objects that endure, causes that precede effects in a clear sequence. The idea that something could exist just long enough to matter and then vanish without a trace feels almost like a contradiction. But the vacuum is full of these contradictions. Every point in space is alive with tiny acts of creation and annihilation. Not dramatic explosions, not visible flashes, just subtle, relentless activity that never quite resolves into something solid. It is tempting to think of these fluctuations as noise, as meaningless background chatter. But noise, by definition, is something you can ignore. The universe does not ignore this. In fact, some of the most precise predictions in physics rely on these fluctuations being exactly what they are. Without them, atoms would behave differently. Forces would not have the strengths they do. The universe would not look the way it does. What we casually dismiss as nothingness turns out to be essential. This introduces a strange inversion of causality. Instead of particles creating fields, fields exist first. Instead of events generating space, space shapes events. Instead of emptiness being the absence of structure, it becomes the deepest structure of all. At this point, the idea of a vacuum begins to resemble something less like a void and more like a medium. A medium is something that supports activity. Water supports waves. Air supports sound. Fabric supports tension. A medium does not need to act intentionally to shape what passes through it. It simply needs to exist. The quantum vacuum behaves like this kind of medium. It supports fluctuations. It allows particles to emerge. It sets the rules for how forces propagate. It determines what is possible and what is forbidden. Yet it does all of this without ever becoming visible itself. This invisibility is crucial, because if the vacuum were visible, we would treat it as an object. We would point to it. We would draw boundaries around it. We would assume it could be isolated. But it cannot. The vacuum is not something inside space. It is what space is. Every region of the universe shares it. There are no edges where it stops, no gaps where it disappears. Even inside atoms, even between quarks, even in the coldest voids between galaxies, the vacuum remains. This continuity is unsettling. If the vacuum were localized, we could avoid it. If it existed only in certain regions, we could study it as an exception. But because it is everywhere, it becomes unavoidable. You are immersed in it right now, not metaphorically. Physically, every atom in your body is stabilized by interactions that depend on the structure of the vacuum. Every chemical bond exists within fields that fill all of space. Even the notion of here and there relies on the vacuum behaving consistently from one location to another. The vacuum is not behind the universe. It is not beneath it. It is not surrounding it. It is the condition that allows universe to be a meaningful word. This realization introduces a subtle tension. If the vacuum is active everywhere, then no region of space is ever truly isolated. Even the most distant voids between galaxies are connected by the same underlying structure. They share the same restless baseline. This means that emptiness is not a separation. It is a connection. When we imagine the space between stars, we picture distance. We picture isolation. We picture vast, cold nothingness stretching endlessly. But the vacuum does not respect our sense of separation. It is continuous. It links all points in space through shared fields and shared fluctuations. In a sense, everything touches everything else through the vacuum. Not directly, not mechanically, but structurally. This idea quietly erodes another assumption, that influence requires contact or signals, that something must travel from one place to another to create an effect. In the quantum vacuum, influence is built into the fabric itself. Changes in conditions in one region can alter the behavior of fields everywhere. Boundaries matter. Geometry matters. Configuration matters. The vacuum responds not only to what is present, but to what is possible. This is not communication in the human sense. There are no messages, no intent, no direction. But there is sensitivity. The vacuum is sensitive to structure. This sensitivity becomes most apparent when we attempt to constrain it, when we place objects close together, when we impose boundaries, when we alter geometry. The vacuum reacts, not dramatically, quietly. Forces emerge where none should exist. Energies shift, pressures appear. The nothingness pushes back. This should disturb us more than it does, because it suggests that empty space is not indifferent to being shaped. It is not a blank canvas that accepts whatever we impose upon it. It responds, it resists, it adjusts, and response implies participation. At this stage, many physicists are careful with their language. They emphasize that the vacuum does not think, it does not decide, it does not observe in any conscious sense. And they are right. But consciousness is not required for influence. A magnet does not intend to attract iron, yet it does. Gravity does not choose to curve space, yet it does. A lens does not plan to bend light, yet it cannot help itself. The vacuum behaves similarly. It does not need awareness to matter. It simply needs rules. And those rules allow for a universe that is never truly still. Raises a quiet, unsettling possibility. If the vacuum is always active, always fluctuating, always shaping the behavior of particles and forces, then it is never a passive stage. It is always involved. And if it is always involved, then there is no moment, no region, no condition in which nothing at all is happening. The universe never reaches silence. Even in its emptiest places, even in its coldest voids, even in the absence of stars, matter, and light, there is still motion, still tension, still possibility. Emptiness, it seems, is not the absence of reality. It is reality at its most stripped-down form. This reframes how we think about the space between stars. It is not a gap waiting to be filled. It is not a pause between meaningful events. It is the continuous foundation upon which all events unfold. Stars are not interruptions in emptiness. They are patterns within it. Galaxies are not islands in nothingness. They are concentrations shaped by the same underlying sea. And if this is true, then the emptiest regions of space are not where the universe is least active. They are where its deepest rules are most exposed, which leads to a question that physics rarely asks out loud, but which quietly lingers beneath the equations. If the vacuum is always active, always fluctuating, always shaping outcomes, then is it truly neutral? Or does it carry a kind of memory, a record of interactions encoded not in particles, but in structure? That question does not demand an answer yet. It only asks for patience. Because before we can ask whether emptiness remembers, or responds, or influences the future in subtle ways, we need to understand something even more fundamental. We need to understand whether the vacuum is merely active, or whether it is relational, whether it simply exists, or whether it is constantly interacting with everything that passes through it. That is where the next drift begins. If the vacuum were merely active, that alone would already challenge our intuition. But activity is not the most unsettling part. What truly destabilizes our understanding is how that activity manifests. The universe does not fill empty space with stable things. It fills it with appearances, not objects, not particles that persist, but brief events that exist just long enough to matter. They emerge without warning. They vanish without trace. And yet, they influence reality as if they had always been there. These are what physicists call virtual particles. At first, the name sounds dismissive. Virtual suggests artificial, simulated, less real. But this is a linguistic accident, not a scientific judgment. Virtual particles are not fake. They are not imaginary. They are simply constrained by time in a way that ordinary particles are not. They exist on the edge of what is allowed. To understand why they appear at all, we need to let go of another deeply rooted assumption, that existence requires permission from observation. In everyday life, something exists because we can see it, touch it, measure it. Existence feels tied to persistence. If something vanishes before we notice it, we tend to treat it as irrelevant. The quantum vacuum does not care about notice. At the smallest scales, reality is governed by probabilities, not guarantees. Energy can fluctuate as long as it settles back quickly enough. The universe allows brief violations of stillness, provided they are repaid almost immediately. This is not chaos. It is accounting. Energy is borrowed. Time is charged. Balance is restored. Within this narrow window, particles can briefly appear. They are born not from collisions, not from stars, not from heat or pressure, but from the structure of the vacuum itself. They do not travel from somewhere else. They do not arrive carrying information. They simply arise where the rules permit. This is the first quiet twist. Virtual particles do not require a cause in the way we normally understand causation. They do not need an event to precede them. They are permitted by the background condition of reality. In other words, emptiness generates events without being triggered. This should make us uneasy, because causation is one of the few anchors the human mind relies on to feel safe. Something happens because something else happened. Effects follow causes. Nothing appears from nowhere, except here. Vacuum. Appearances are not responses. They are expressions. The fields that fill space are restless by nature. Their lowest energy state is not motionless. It is a constant, subtle trembling. And that trembling is enough to produce momentary excitations. Virtual particles are those excitations given form, however briefly. They come in pairs, one carrying positive energy, the other negative. They appear together, exist together, and disappear together, canceling each other out before the universe has to account for them in full. But during their fleeting existence, they can interact with real particles. They can alter trajectories. They can shift energy levels. They can change outcomes. Their presence is inferred, not seen. This creates a strange hierarchy of reality. There are things that exist because they persist, and there are things that exist because they influence. Virtual particles belong to the second category. They do not need duration to matter. They do not need identity. They do not need to be observed. They only need to interact. This undermines another comforting belief, that what is real must be stable. In the quantum vacuum, stability is optional. Influence is not. Consider how unsettling this is when scaled up to the vast emptiness between stars. We imagine that space as inert, a place where nothing happens unless something enters it. But at every point in that emptiness, virtual particles are constantly appearing and disappearing. Not occasionally, not rarely, constantly. Every cubic centimeter of empty space is alive with this activity, not in bursts or pulses, but as a continuous background hum, a ceaseless flicker of potential becoming momentarily actual, then dissolving back into possibility. This is not poetic exaggeration. It is the most conservative interpretation physics allows, and yet these events leave no direct trace. They do not accumulate, they do not build structures, they do not form patterns we can easily detect. They are like thoughts that vanish before becoming memories, which raises a subtle question. If something can exist, interact, and disappear without leaving a trace, what does it mean to say that it existed at all? We are uncomfortable with this question because it blurs the boundary between being and not being. It suggests that existence may not be a fixed category, but a gradient. Virtual particles occupy that gradient. They are not fully real in the classical sense, but they are not unreal either. They exist in the only way the vacuum allows them to exist. and the vacuum allows a lot. This brings us to the second twist. Virtual particles are not rare anomalies. They are not exceptions to the rule of emptiness. They are the rule. Empty space is defined by their presence. If the vacuum did not fluctuate, if virtual particles did not appear, the universe would behave differently at every scale. Atoms would not hold together the same way. Forces would not have the strengths we measure. Even the stability of matter would be altered. In a very real sense, matter depends on things that never quite exist. This is a deeply counterintuitive idea. We like to believe that solid things are built from solid components, that permanence emerges from permanence. But quantum reality reverses this logic. Stability emerges from instability. Atoms are stable not because their components are static, but because the underlying vacuum is restless in a very precise way. The flickering of virtual particles corrects, adjusts, and balances forces continuously. Matter is not resting on emptiness. It is surfing it. This metaphor is uncomfortable because it removes the idea of a firm foundation. Surfing implies movement, adjustment, constant correction. It implies that falling is always possible. But the universe has been surfing its vacuum for billions of years without wiping out, which suggests that the vacuum is not chaotic. It is structured. Its fluctuations are constrained. Its rules are consistent. Its behavior is predictable in the aggregate, even if unpredictable in detail. This predictability is what allows us to build theories. But it also hides something unsettling. Predictable does not mean passive. The vacuum does not wait for matter to arrive before it becomes active. It does not sit idle between events. It does not turn off when no one is watching. It is always generating appearances, and appearances are a form of participation. At this point, the mind naturally tries to reassure itself. These are just mathematical artifacts, just convenient ways to calculate interactions. Virtual particles are not really there. They are tools, not things. This argument has been made many times, and it is not entirely wrong. Virtual particles cannot be directly detected. They are not objects in the same sense as electrons or photons. But dismissing them as mere mathematics misses the deeper issue. The mathematics works because it reflects something real about how the vacuum behaves. When predictions depend on these fluctuations, and experiments confirm those predictions with extraordinary precision, it becomes difficult to argue that nothing is happening. You can debate the ontology. You cannot deny the effect. And effects imply presence. Even if we refuse to call virtual particles real, we are forced to accept that empty space behaves as if it were full of fleeting entities. And behavior is harder to dismiss than terminology. This brings us to the third twist, quieter but more disturbing. If the vacuum can generate appearances without external cause, and if those appearances can interact with real particles, then the vacuum is not merely reacting to the universe. It is co-creating it, not deliberately, not consciously, but structurally. The vacuum sets the stage, writes the rules, and participates in every interaction by providing the conditions under which it occurs. Nothing escapes this participation. Even in the most isolated regions of space, where no stars shine and no particles pass through for millions of years, the vacuum continues its silent activity. Appear, disappear, adjust, balance. It is tempting to think of this as background noise, something that averages out to nothing over time. And in many cases, it does, but not always. Sometimes, these fluctuations leave subtle imprints, tiny biases, slight asymmetries, differences that grow over time. A small fluctuation in the early universe can become a galaxy. A tiny imbalance can shape cosmic structure. A brief appearance can cascade into permanence. The vacuum does not choose which fluctuations matter. It does not favor outcomes, but by allowing fluctuations at all, it makes history possible. Without instability, nothing new could ever happen. This reframes emptiness again. Empty space is not the absence of events. It is the generator of possibility. And generators are never neutral. They do not decide outcomes, but they determine what outcomes are allowed. This realization lingers, unresolved, because it opens a door we are not yet ready to walk through. If the vacuum generates appearances, and if those appearances can influence reality, then the boundary between background and foreground begins to blur. What we thought was merely between things starts to look more like a continuous participant. And participation invites a dangerous question. If something participates in every interaction, shapes every outcome, and never stops fluctuating, then is it truly indifferent? Or does it, in some subtle way, respond to the presence of matter itself? That question does not end here. It drifts forward, carried by the same fleeting entities that appear and vanish in the space between stars, leaving behind no trace except their influence. In the next drift, we will begin to explore whether these fleeting appearances are truly random, or whether the vacuum is sensitive to the structures that move through it. And that sensitivity, if it exists, changes everything. There is a word we use when we want to describe absolute calm: silence. Silence feels final, complete, a condition where nothing moves, nothing intrudes, nothing demands attention. We imagine silence as a kind of endpoint, a place beyond disturbance. But physics does not recognize silence. What we call silence is only the limit of our perception, a range where vibrations fall below what our senses can register. Sound waves too soft, motions too subtle, energies too small to announce themselves. The universe, however, does not lower its voice just because we stop listening. At every scale we have ever examined closely enough, motion persists. Even when temperature approaches absolute zero, even when particles are removed, even when radiation is absent, there is always something shifting, adjusting, trembling. This trembling is not incidental, it is fundamental. At the deepest level, reality is not built from things, but from oscillations. Fields rise and fall, values fluctuate, quantities refuse to settle into exact numbers. Stillness, in the absolute sense, is not just rare, it is forbidden. This is the Roin-Han, because it dismantles one of our most basic assumptions, that nothingness is calm. The vacuum is not calm. It vibrates, not like a string you can pluck, not like a wave you can see, but like a condition that cannot hold itself perfectly still. No matter how empty it becomes, this vibration has no direction, no rhythm we can tap our foot to, no frequency that announces itself. It is not sound. It is not motion through space. It is fluctuation of possibility. At any given moment, the energy of the vacuum is slightly higher here, slightly lower there. These differences are not caused by anything external. They arise spontaneously, governed only by the rules that prevent certainty from ever becoming complete. This introduces a quiet but profound twist. The vacuum does not fluctuate because something disturbs it. It fluctuates because not fluctuating is not allowed. Stability, in the absolute sense, is not the natural state of reality. Instability is. We often imagine the universe as something that began chaotic and slowly settled down. Stars formed, galaxies organized, structures emerged, calm followed violence. But at the deepest level, calm never arrived. The universe did not settle. It learned to balance. Balance is not stillness. Balance is constant correction. A tightrope walker is never motionless. Muscles adjust, weight shifts, micro movements occur continuously. To an observer, the walker appears steady, but that steadiness is maintained through perpetual motion. The vacuum behaves in the same way. Its apparent emptiness masks an endless series of adjustments. Tiny fluctuations appear and disappear, not to create drama, but to maintain the lowest energy state allowed by the rules of reality. This is the Nang Sorm. Because once you understand this, the vacuum stops feeling chaotic and starts feeling constrained, not wild, not random in the everyday sense, but disciplined. The fluctuations are small, they are bounded, they follow precise statistical patterns. They do not grow without limit. They do not accumulate unchecked. The vacuum is restless, but not unstable. This distinction matters. Restlessness suggests motion without purpose. Instability suggests collapse. The universe permits the former, but not the latter. So empty space is not a seething chaos. It is a finely tuned, continuously adjusting condition that never quite rests, yet never breaks apart. This is where many explanations stop, content to leave the vacuum as a technical curiosity. But there is another layer, because fluctuation is not just noise. Fluctuation carries information. Every time a field fluctuates, it momentarily takes on a different configuration, a slightly different arrangement of energy, a different relationship between values. These configurations do not persist long enough to become events, but they exist long enough to matter. This is the twist that rarely gets discussed. Information does not require memory in the human sense. It does not require storage. It does not require awareness. It only requires distinguishable states. If the vacuum can exist in slightly different states from moment to moment, then it carries information about those states, even if that information is never recorded permanently. The vacuum, then, is not a blank. It is a constantly updating pattern. Most of these patterns cancel out. They average to zero over time. They leave no trace. But cancellation is not the same as absence. When two waves cancel, they still existed. When two numbers sum to zero, they still had value. When two fluctuations balance out, they still occurred. This suggests something unsettling. The vacuum is continuously exploring possibilities. Not intentionally, not strategically, but structurally. The rules of quantum mechanics force it to sample configurations. However briefly, reality, at its most stripped-down level, is not static, it is exploratory. It reframes how we think about the space between stars. We imagine it as empty because nothing persists there. No matter, no radiation, no visible motion. But persistence is not the same as activity. The vacuum is active without producing objects. It fluctuates without leaving debris. It moves without going anywhere. This makes it difficult to visualize because we are used to associating motion with displacement. Something moves from here to there. Something changes position. Something travels. The vacuum does none of this. Its motion is internal, relational, a shift in values rather than locations. This kind of motion is easy to overlook because it does not announce itself through change in scenery. Nothing seems to move because nothing goes anywhere. But something is always happening. Imagine an ocean with no surface waves, no current strong enough to drift a boat, no tides you can measure. And yet, at every depth, water molecules vibrate. They exchange energy. They shift positions minutely, constantly. From a distance, the ocean appears perfectly still. From within, it is alive with motion. The vacuum is like this ocean, except the motion is not molecular, and the depth has no bottom. This brings us to another twist, quieter but more disturbing. If the vacuum is always fluctuating, then it is never in exactly the same state twice. Even if those differences are unimaginably small, they exist. The universe does not repeat itself perfectly. Every moment is slightly different from the last, not because events change, but because the baseline itself shifts. This undermines the comforting idea that time passes over an unchanging background, that events happen on space and in time. Instead, space and time are part of the same restless fabric. The vacuum's fluctuations are not happening in time. They are part of what time is. Time does not flow over a static stage. It emerges from the continuous updating of reality's lowest level conditions. This is not a claim. It is an implication drawn from the mathematics. If energy cannot be perfectly fixed, and if time is tied to energy through uncertainty, then the passage of time is inseparable from fluctuation. Stillness would imply timelessness, but the universe has time. Therefore, it must fluctuate. This is a subtle but profound inversion. We usually think of time as something that allows change, but at the deepest level, change is what allows time. The vacuum's refusal to remain still is not a flaw. It is the mechanism by which time remains meaningful, which raises an unsettling thought. If time depends on fluctuation, and fluctuation exists even in the emptiest regions of space, then the passage of time does not stop anywhere. There is no timeless void, no frozen nothingness, no region where the universe pauses. Even between stars, even between galaxies, even in the darkest cosmic deserts, time flows because the vacuum does not rest. This challenges another assumption, that emptiness is inert and therefore irrelevant to history. But history, at its most fundamental level, is a sequence of states, and the vacuum provides those states continuously, whether or not anything dramatic occurs. The universe is not a series of events separated by empty intervals. It is a continuous drift of conditions, punctuated by visible structures. Stars, planets, galaxies, these are not interruptions in emptiness. They are amplifications of patterns that already exist at the vacuum level. This idea is unsettling because it removes the sense of isolation we assign to empty space. The space between stars is not waiting. It is not idle. It is not blank. It is actively maintaining the conditions that allow the universe to remain a universe. And if conditions are always being maintained, then maintenance itself becomes a form of participation. This is where the discomfort deepens. Participation implies relationship, not intention, not awareness, but interdependence. If matter depends on the vacuum's fluctuations to exist as it does, then matter and emptiness are not opposites. They are phases of the same process. Matter is what happens when fluctuations align and persist. Emptiness is what happens when they do not. But both are expressions of the same underlying activity. This dissolves the boundary between something and nothing. There is no hard edge where existence ends and emptiness begins. There is only a gradient of persistence, from fleeting fluctuations to long-lived structures. And that gradient is continuous, which leads us to a question that quietly emerges from all of this. If the vacuum is always fluctuating, always updating, always maintaining conditions, then how does it respond when those conditions are altered? What happens when matter enters a region of space? When boundaries are introduced? When geometry changes? Does the vacuum simply continue fluctuating, indifferent to what passes through it? Or does it adjust subtly, quietly, to the presence of structure? That question does not resolve here. It drifts forward, carried by the same restless motion that prevents emptiness from ever becoming truly empty. And in that drift, we begin to approach a more unsettling possibility, that the vacuum is not just active, but sensitive. And sensitivity, once introduced, changes how we must think about the space between stars. When physicists say the vacuum is sensitive, they do not mean it reacts emotionally. They mean something far stranger. They mean the vacuum responds to structure. This is difficult to accept at first, because we are trained to think of space as neutral, something that simply allows things to exist within it, a passive container that does not care what occupies it. But the deeper physics goes, the less that picture holds. At the most fundamental level, space is not empty territory waiting to be filled. It is a network of fields that exist everywhere, regardless of whether matter is present. These fields are not optional. They are not added later. They are not consequences of particles. they come first. Particles are disturbances in fields. Forces are interactions between fields. And what we casually call empty space is simply the region where fields exist without persistent disturbances. This is the Rori Nan, because it removes the idea that matter is primary. If fields exist everywhere, and if particles only exist as localized excitations of those fields, then matter is not what space contains. Matter is what space does. This reframing is subtle but destabilizing. It suggests that the universe is not built from objects moving through emptiness, but from continuous structures expressing themselves in different ways. A field is not a thing you can point to. It does not have edges. It does not occupy a location in the way objects do. It assigns values to every point in space, continuously. Temperature fields, magnetic fields, electric fields, quantum fields. Some of these we can feel, some we can measure. Others only reveal themselves through indirect effects. But all of them share one unsettling property. They exist even when nothing else does. Remove all particles from a region of space, and the fields remain. They do not vanish. They do not thin out. They do not weaken. They simply persist in their lowest energy configuration. This lowest energy configuration is what we call the vacuum. But calling it a vacuum hides its true nature, because this nothing is actually a layered structure of interacting fields, each with its own rules, constraints, and modes of fluctuation. The vacuum is not a single thing. It is a superposition of many fields, overlapping everywhere. This is where the Nung sum occurs. Because once you see the vacuum as a field configuration rather than a void, its activity begins to make sense. Fields fluctuate because they cannot be perfectly still. Fields respond to boundaries because boundaries alter the conditions they must satisfy. Fields interact because their equations are coupled. Nothing mystical is required, and yet the implications remain unsettling. Fields do not simply exist independently of matter. They interact with matter continuously. When a particle moves through space, it does not travel through nothing. It moves through fields that influence its behavior at every moment. Its mass arises from interactions with fields. Its charge determines how it couples to fields. Its stability depends on field configurations remaining consistent. Matter is not separate from the vacuum. It is embedded within it. This is where the twist deepens. If the vacuum is a configuration of fields, then changing the environment changes the vacuum itself. Introduce matter, and the fields adjust. Introduce boundaries, and the fields rearrange. Change geometry, and the fields respond. The vacuum is not fixed. It is contextual. This is not a metaphor. It is measurable. When objects are placed close together in otherwise empty space, forces appear that should not exist if the vacuum were truly indifferent. The presence of boundaries alters which fluctuations are allowed and which are suppressed. The vacuum adapts, not intelligently, not intentionally, but inevitably. Its structure responds to constraints the same way water responds to a container. The water does not choose its shape. It takes it. The vacuum behaves similarly. Constrain it, and its fluctuations shift. Shape it, and its energy changes. Define limits, and new effects emerge. This tells us something crucial. The vacuum is not merely active, it is relational. It does not exist in isolation from what occupies space. Its behavior depends on context, on configuration, on structure. This breaks the last illusion of emptiness as neutrality. Neutral things do not respond. Backgrounds do not adapt. Passive stages do not change their properties when actors enter, but the vacuum does. This forces us to reconsider what it means for space to be between things. If the vacuum were simply between stars, it would not care whether stars were there or not. But because its properties shift in response to matter, it is not merely between, it is involved. This involvement is quiet, precise, and relentless. It does not announce itself with explosions or signals. It reveals itself only through subtle deviations from what classical intuition predicts. But those deviations matter. They tell us that space is not a container, it is a participant. This is deeply uncomfortable for the human mind, because participation implies influence, and influence implies consequence. If the vacuum influences matter, even subtly, then it shapes outcomes. It affects trajectories. It alters probabilities. And probabilities are the raw material of reality. At the quantum level, what happens is not determined in advance. It is constrained by conditions. And the vacuum provides those conditions everywhere. Every interaction occurs within the vacuum structure. Every outcome is filtered through its rules. Even randomness is shaped by the background in which it unfolds. Random does not mean unstructured. It means unconstrained, beyond certain limits. The vacuum sets those limits. This leads to a realization that feels almost dangerous. If the vacuum is everywhere, and if it responds to structure, then it is never the same in two different situations. The presence of matter here changes the vacuum there, not through signals or forces in the classical sense, but through shared field configurations. Space is not locally isolated. It is globally connected. This does not mean information travels instantly or causality is violated. It means that the underlying conditions of reality are continuous across space. There is no seam where the vacuum ends and begins again. Everything exists within the same field framework. This continuity gives rise to a subtle form of coherence, not coordination, not planning, but consistency. The universe behaves as a single system because the vacuum is a single system. This is where the thought becomes unsettling. If the vacuum is a system, then it has states. If it has states, then it can change states. If it can change states, then it can respond. Again, not consciously, not intentionally, but structurally. The vacuum does not observe, but it registers. It does not remember in the human sense, but it carries forward conditions that affect future possibilities. This idea sits at the edge of what physics is comfortable discussing, because it blurs the line between background and participant, between stage and process. But the mathematics keeps pointing in this direction. Space is not an empty backdrop. It is a field environment that adapts to what exists within it, and environments shape behavior. Every organism behaves differently in water than in air. Every process unfolds differently under pressure than in a vacuum. Every structure responds to the medium it inhabits. Matter is no exception. Matter behaves the way it does because of the vacuum it inhabits. It leads to a question that feels almost inevitable now. If the vacuum responds to structure, then what happens when the structure becomes complex? What happens when matter organizes itself into atoms, molecules, stars, galaxies? Does the vacuum simply accommodate these structures passively? Or does complexity itself alter the background conditions in subtle ways? This question does not imply awareness. It does not require intention. It only requires sensitivity. And we have already established that the vacuum is sensitive. So as we move forward, we must begin to explore how this sensitivity scales, from single particles to collections of matter to vast cosmic structures. Because if the vacuum responds differently to different configurations, then emptiness is not uniform. And a non-uniform emptiness is no longer just emptiness. It becomes a dynamic landscape, one that may hold more influence over the universe than we are prepared to admit. At some point, the language we use begins to betray us. We say that space contains fields, that the vacuum holds energy, that matter moves through emptiness. These phrases feel natural because they mirror how we interact with the world. A room contains air, a river holds water, A road allows cars to pass through it. Containers make sense to us. But the universe does not seem to be built that way. As physics has peeled back layer after layer of reality, the idea of space as a container has quietly fallen apart. Not with a dramatic collapse, but with a slow erosion, as evidence accumulated and metaphors failed. Space does not contain the vacuum. Space is the vacuum. This is the Rorinon. Because once you accept this, the entire mental model shifts. There is no longer a background plus contents. No empty box waiting to be filled. No stage separate from the play. There is only a continuous structure expressing itself in different ways. When we say that the vacuum is made of fields, we are not describing something added to space. We are describing what space fundamentally is. The fields are not inside space. They define it. This distinction sounds subtle, but it is radical. Imagine trying to describe the ocean as a container for water. The idea collapses immediately. The ocean does not hold water. It is water. Waves, currents, pressure gradients, these are not things happening in the ocean. They are things the ocean does. Space behaves the same way. Particles are not objects traveling through an independent arena. They are localized behaviors of the underlying field structure. Forces are not messages sent across space. They are changes in field relationships. Nothing moves through space. Everything moves as space. This is difficult to accept because it strips away the comfort of separation. We like to think that objects are independent entities navigating a neutral environment. But physics keeps pointing toward a universe where independence is an illusion. There is only relationship. Fields relate to each other. Excitations relate to fields. Structures relate to the vacuum. And these relationships define what can happen. This leads to the Nang Som, because once the container metaphor is dropped, many puzzles become clearer. Why particles cannot be fully isolated. Why forces have finite ranges. Why properties like mass and charge are not intrinsic objects but relational quantities. A particle's mass is not something it carries around like luggage. It is the result of how that excitation interacts with surrounding fields. Change the field environment, and the particle's effective mass changes. Charge is not a thing inside a particle. It is a way of describing how that excitation couples to electromagnetic fields. Even identity becomes relational. An electron is an electron not because of some hidden essence, but because it behaves the same way everywhere in the same field structure. Its identity is a pattern, not a substance. This reframing is comforting for a moment. It feels elegant, unified, clean. But then the twist arrives. If space is not a container but a continuous structure, then there is no true separation between regions of space. There are no isolated pockets where the vacuum behaves independently of the rest. The vacuum is global. Changes in configuration here alter the field relationships everywhere, not through signals traveling faster than light, but because the underlying structure is shared. This does not violate causality. Nothing transmits information instantaneously. But it does mean that the universe is more interconnected than classical intuition allows. The background is not something each region owns privately. It is something all regions share. This makes emptiness profoundly non-local. When we imagine the vast emptiness between stars, we imagine distance. We imagine separation. We imagine isolation so complete that nothing can bridge it. But if the vacuum is a single, continuous field structure, then distance is not separation in the deepest sense. It is only a measure of how excitations relate within the same underlying medium. 2 points in space are not disconnected. They are differently related. This idea feels abstract, but it has concrete consequences. In quantum theory, the vacuum state is defined globally. You cannot define it for one region without referencing the rest. The idea of a local vacuum is an approximation, not a fundamental truth. This means that Emptiness is not something you can carve up into pieces. You cannot say, this part of space is empty, that part is not. In any absolute sense, emptiness is a property of the whole. This realization quietly undermines one of our most cherished intuitions, that the universe is made of parts that can be fully separated. At the deepest level, separation is provisional. This brings us to another twist, one that feels almost philosophical. If space is a continuous structure rather than a container, then the distinction between foreground and background collapses. There is no stage behind events. Events are expressions of the same thing that appears empty when nothing persistent happens. The universe does not have a backdrop. It has a texture, and textures are felt even when nothing moves across them. This is why the vacuum can influence outcomes without acting, why it can shape behavior without intention, why it can participate without awareness. It is not an external agent. It is the medium of existence itself. This makes the phrase, "between the stars," deeply misleading. There is no between. Stars are dense patterns within the same continuous structure that extends everywhere. The space around them is not different in kind, only in degree. Stars are loud regions of the vacuum. Empty space is quiet regions of the same thing. But quiet does not mean inactive. This dissolves the comforting idea that emptiness is separate from matter, that there is a clear boundary where objects end and nothing begins. Instead, there is a gradient. Dense excitation fades into sparse excitation. Structure dissolves into fluctuation. Matter gives way to vacuum without a sharp edge. The universe is not a collection of things floating in nothingness. It is a single process expressing itself unevenly. This thought has consequences that extend far beyond physics. If there is no true separation between space and what exists within it, then existence itself is relational at every level. Nothing exists entirely on its own. Everything depends on the structure it inhabits. Even emptiness depends on itself. This dependency is subtle, but it means that the vacuum cannot be indifferent to what emerges within it, not because it cares, but because it is the same thing. A wave does not observe the ocean, but it cannot escape it. A ripple does not influence water intentionally, but it alters the surface all the same. Matter is a ripple. The vacuum is the ocean, and oceans respond to ripples, not with awareness, but with dynamics. This is where the discomfort deepens. If the vacuum is the fundamental structure of reality, and if everything that exists is a pattern within it, then there is no place outside the vacuum from which to observe it. We are not looking at emptiness. We are inside it. Every measurement we make, every equation we write, every concept we form, all of it emerges from within the same structure we are trying to understand. There is no external vantage point. This means that our descriptions of emptiness are necessarily incomplete. We are using tools forged within the vacuum to describe the vacuum itself, and self-description is always limited. This does not mean understanding is impossible. It means it is asymptotic. We can approach clarity, but never reach a final picture. The vacuum remains partially opaque, not because it hides, but because it is what we are made of. This leads to a quiet but profound shift in perspective. The question is no longer, what is inside empty space? It's so full. The question becomes, what is space doing when nothing stands out? If you are. And that question opens another door. Because if space is a continuous structure, and if it responds to configuration, then complexity itself may alter how the vacuum behaves. Not just matter versus emptiness, but simple patterns versus complex ones. As we move forward, we will begin to explore how complexity changes the relationship between matter and the vacuum. Because once structure becomes rich enough, the distinction between background and participant may blur even further. And in that blur, the idea that emptiness is passive becomes increasingly difficult to defend. Long before physics tried to describe emptiness, the human mind had already decided how it felt about it. We feared it. Not consciously, not always dramatically, but instinctively. Emptiness triggered unease long before it triggered curiosity. An empty landscape meant danger. An empty sound meant something was wrong. An empty gaze meant absence, loss, or threat. This fear did not arise from philosophy. It arose from survival. In the natural world, emptiness often signaled vulnerability, a clearing with no cover, a silence where predators might be near, a gap where something should have been. Emptiness was not neutral. It was suspicious. This is the Rory Hun, because it reveals something uncomfortable. Our idea of empty space has never been purely scientific. It has always been emotional. When we look at the vast darkness between stars and call it empty, we are not making a careful measurement. We are projecting an ancient instinct onto a cosmic scale. We are reading the universe through a nervous system that evolved to avoid open ground. This projection matters more than we like to admit, because fear shapes interpretation. It pushes us toward simplifying metaphors. It makes us want emptiness to be harmless, inert, non-interactive, a place where nothing can surprise us. Calling space empty is not just a description. It is a reassurance. If nothing is there, nothing can happen. But physics keeps refusing to provide that comfort. As soon as we examine emptiness closely enough, it stops behaving like a void and starts behaving like a presence, a subtle one, a quiet one, but a presence nonetheless. And presence reactivates fear. Not the sharp fear of immediate danger, but the deeper discomfort of uncertainty. The sense that something exists beyond our awareness, influencing outcomes without announcing itself. This discomfort is ancient. Across cultures and eras, emptiness has been treated with suspicion. Myths filled voids with spirits. Religions described chaos lurking beyond order. Philosophies debated whether nothingness could exist at all, or whether it was a logical impossibility. The vacuum, long before it was a physical concept, was a psychological problem. Human thought has always struggled with the idea that something could exist without form, without identity, without clear boundaries. We are pattern-seeking creatures. We trust shapes. We trust edges. We trust continuity. Emptiness denies all of these. It has no face, no behavior we can predict easily, no signals we can read. So we fill it. We fill emptiness with meaning, with metaphor, with assumption. And when we do that, we stop seeing what is actually there. This is where the Nang Som arrives. Once we recognize that fear is part of the equation, our interpretation of empty space begins to loosen. We realize that some of our resistance is not scientific, but emotional. The universe does not owe us reassurance. It does not need emptiness to feel safe for us. It only needs to obey its own rules. And those rules do not include human comfort. This recognition allows a small shift, a softening. We stop insisting that emptiness must be nothing, and begin allowing it to be something unfamiliar instead. But unfamiliarity has a cost. Because once emptiness is allowed to exist as an active condition, a new unease emerges. Not fear of absence, fear of exposure. Empty space is not empty. Then there is no place where nothing touches us. No region where we are truly isolated from the universe's deeper processes. We are not surrounded by nothingness. We are immersed in something we barely understand. This is the first twist. The fear of emptiness may actually be a fear of intimacy. Not intimacy with other beings, but with the underlying structure of reality itself. The idea that we are never separate, never insulated, never fully detached from the conditions that shape existence. Even in the cold vacuum between stars, the same fields that define our atoms persist. The same fluctuations that influence distant particles also exist here. There is no clean break between here and out there, and any five. This collapses a comforting boundary. We like to imagine ourselves as local phenomena, small islands of complexity surrounded by vast nothingness. It makes our fragility easier to accept. But if emptiness is not nothingness, then we are not islands. We are patterns embedded in a continuous sea. And seas have currents. This brings us to another layer of discomfort. If emptiness is active, fluctuating, and relational, then it is not merely the absence of interaction. It is a medium through which interaction is always possible. The vacuum does not isolate. It connects. Connection, in this sense, does not mean communication. It does not imply messages or signals. It means shared conditions. Everything that exists shares the same vacuum, the same field structure, the same baseline of fluctuation. This shared foundation makes the universe coherent. But coherence can feel threatening when we expect separation. The fear here is subtle. It is not the fear of being watched. It is the fear of being unavoidable. No matter where you go in the universe, the vacuum is there, not behind you, not around you, but as the condition of your existence. There is no escape from it because there is no outside. This idea echoes through human thought in unexpected ways. The fear of silence, the discomfort of isolation, the unease of being alone with one's thoughts. We associate emptiness with loss because emptiness removes distractions, and distraction is how we avoid confronting deeper conditions. The vacuum, in its quiet persistence, does not distract, it does not entertain, it simply exists relentlessly, everywhere. This leads to the second twist. What if our fear of emptiness is not fear of nothing, but fear of being confronted with the fundamental structure of reality without filters? Stars are comforting. They shine. They burn. They behave dramatically. They give us something to focus on. The space between them does not. It offers no spectacle, no narrative, no obvious event. It is easy to ignore until we realize that it never ignores us. This realization does not require attributing awareness or intention to the vacuum. It requires only acknowledging that the vacuum is always present, always influencing, always setting the conditions under which we exist. Presence without personality, influence without intent. This combination is deeply unsettling to a mind that prefers agency to be visible. We trust dangers we can see. We distrust conditions we cannot. This distrust has shaped centuries of thought. It has pushed us to focus on objects, forces, and events, while treating the background as irrelevant. But the background has been doing more work than we realized. This is where the third twist begins to surface. If emptiness has always frightened us, and if that fear has shaped how we describe it, then our scientific language may be subtly biased. Not wrong, but incomplete. We may have underestimated the vacuum not because it is insignificant, but because it does not behave like the things we evolved to notice. It does not threaten directly. It does not announce itself. It does not change rapidly enough to trigger alarm. It is simply always there. And always there is easy to ignore until it isn't. As our instruments become more sensitive and our theories more refined, the vacuum keeps revealing itself as more structured, more influential, and more deeply woven into reality than we expected. Each revelation chips away at the idea that emptiness is safe. Not dangerous in a dramatic sense, not hostile, but not neutral either. The fear shifts from panic to humility. Begin to suspect that the universe is not built around what we notice, but around what persists quietly in the background. And the background, it turns out, is not empty at all. This leaves us with a lingering tension. If our fear of emptiness has led us to misinterpret it, then understanding the vacuum requires more than better equations. It requires confronting the psychological filters we bring into our observations. We must learn to look at emptiness without demanding reassurance from it. without insisting that it be harmless, without insisting that it be inert. Only then can we begin to ask a more precise question. Not why is the universe empty, end quote, but what role does emptiness play in shaping everything that exists, end quote. That question does not end here, because once we allow emptiness to be active, relational, and ever-present, another possibility begins to emerge. That emptiness is not just something we pass through, but something that subtly responds to presence itself. And that possibility leads us directly into the next drift, where emptiness stops feeling like absence and starts feeling like a boundary of perception, a boundary that may not be as one-sided as we once believed. There is a moment, subtle and often unnoticed, when emptiness stops being a physical idea and becomes a cognitive one. It happens when we realize that the universe may not be hiding anything from us at all. It may simply be operating beyond the limits of how we are able to perceive. We tend to believe that what we cannot observe does not exist in any meaningful way. This belief feels reasonable because it aligns with experience. If something cannot be seen, touched, or measured, it rarely affects our daily lives. But physics has been quietly dismantling this assumption for over a century. Some of the most influential structures in the universe are invisible, not because they are hidden, but because our senses were never designed to detect them. This is the Rory Han, because it suggests that emptiness may not be empty in the physical sense, but empty only in the perceptual one. What we call nothing may simply be everything operating outside our sensory bandwidth. Human perception is narrow. We see a tiny slice of the electromagnetic spectrum. We hear vibrations within a small range of frequencies. We feel forces only when they cross certain thresholds. Outside those ranges, the world does not vanish. It continues without us. The vacuum belongs to that outside. It does not glow. It does not sound. It does not press against our skin. So our minds treat it as absence. But absence is a conclusion, not an observation. In science, observation is always mediated. Instruments extend perception, but they do not remove its limits. Every detector is built on assumptions. Every measurement filters reality through a model of what matters. We only measure what we expect might exist. This creates a feedback loop. We define emptiness as the absence of known entities. Then we design instruments to detect known entities. Then we confirm that emptiness contains none of them. The conclusion reinforces itself. But when instruments become sensitive enough to detect deviations from expectation, small anomalies, subtle effects, quiet mismatches, emptiness begins to reveal structure. Not structure we recognize immediately, structure that resists familiar categories. This is where the Nang-Serm enters. Once we acknowledge the limits of perception, emptiness becomes less threatening. We stop demanding that it behave like something obvious. We allow it to exist on its own terms. The vacuum is not silent because it has nothing to say. It is silent because we lack the ears to hear it. This shift opens space for curiosity. Instead of asking why empty space seems inert, we ask what kind of activity could exist without producing familiar signals. What forms of influence could operate without leaving obvious traces? Quantum fields provide one answer. Fluctuations provide another. But these are not the end of the story, because even these descriptions rely on human-designed abstractions. Fields are mathematical constructs. Fluctuations are inferred patterns. They are not things we experience directly. They are translations, and every translation loses nuance. This leads to the first twist. What if emptiness is not merely outside our senses, but outside our conceptual frameworks? The difficulty is not that we cannot see it, but that we do not yet have the right mental categories to describe it. Throughout history, major shifts in understanding have occurred not when new data appeared, but when new ways of thinking emerged. Before gravity was described mathematically, It was a mysterious attraction. Before germs were understood, disease was attributed to imbalance or fate. Before electricity was conceptualized, it was a curiosity. Reality did not change. Language did. The vacuum may be waiting for a similar shift. We describe it as energy, as fields, as fluctuations, because these are the closest tools we have. But closeness is not identity. The vacuum may be something we have not yet learned how to think about properly. This possibility introduces a subtle discomfort. If emptiness lies at the edge of our conceptual reach, then our confidence in describing it must remain provisional. Our equations may work, but they may not capture the whole story. And that story may not be one that fits neatly into existing categories. This brings us to another twist. If the vacuum exists beyond perception and beyond current conceptualization, then our interactions with it are asymmetrical. We are influenced by it constantly, but we are barely aware of that influence. This asymmetry feels unbalanced. In human experience, influence usually comes with awareness. We notice forces that act upon us. We feel pressure, hear sound, see light. The vacuum acts without announcing itself. It shapes trajectories, alters probabilities, stabilizes matter, and constrains outcomes, all without producing sensations. This creates a peculiar relationship. We live inside something that affects us continuously, yet remains largely invisible and conceptually elusive. This is not observation in the human sense, but it is interaction, and interaction without awareness is unsettling. It challenges the assumption that to be affected is to notice. The vacuum suggests otherwise. This realization reframes emptiness yet again. Empty space is not just a physical condition. It is a boundary of awareness. Beyond this boundary, reality continues, structured and active, but inaccessible to intuition. This boundary is not fixed. It moves as our tools and theories evolve. What was once invisible becomes measurable. What was once inconceivable becomes obvious in hindsight. But the boundary never disappears completely. There is always something just beyond it. This leads to a deeper, quieter twist. If emptiness sits at the edge of perception, then it occupies a strange position in our relationship with the universe. It is both fundamental and elusive, essential and overlooked. We build our understanding of reality on what we can detect, but the foundation of that reality lies in what we cannot. This inversion undermines a deeply held belief that knowledge progresses from the ground up, from the most basic elements to the most complex. In the case of the vacuum, the most basic element may be the hardest to grasp, because it does not behave like an element at all. It behaves like a condition. Conditions are difficult to notice because they do not change when we expect them to. They are always there, quietly shaping outcomes without drawing attention to themselves. Air pressure is a condition. Gravity is a condition. Time itself is a condition. We notice them most clearly when they fail or change abruptly. The vacuum, so far, has been remarkably consistent. This consistency makes it easy to ignore. But ignoring something does not make it passive. This brings us to the final twist of this chapter. If emptiness is a boundary of perception, then crossing that boundary does not require traveling through space. It requires a shift in how we interpret what we already inhabit. The space between stars has always been active. The vacuum has always fluctuated. Fields have always existed everywhere. The only thing that has changed is our willingness to take emptiness seriously. This willingness comes at a cost. Once emptiness is no longer dismissed as nothing, we must ask what role it plays in shaping reality beyond mere background conditions. If it is active, relational, sensitive, and foundational, then its influence may extend further than we have acknowledged, not into intention, not into awareness, but into structure. Structure determines what kinds of complexity are possible. As we move forward, the question shifts again. If emptiness defines the limits of perception, then what happens when perception itself becomes part of the system? What happens when observers, not conscious observers, but interacting systems, become embedded deeply enough in the vacuum to alter its behavior? That question does not end here. It drifts forward, carried by the same unseen structure that has always shaped what we can know, without ever asking to be noticed. And in that drift, the idea that emptiness is merely there begins to dissolve. It becomes something closer to an interface, a threshold where reality and understanding meet and quietly fail to align perfectly. For a long time, physics treated emptiness as something that could be ignored until proven otherwise. If nothing was there, nothing should happen. If no particles existed, no forces should act. If space was empty, it should remain silent. This assumption felt so natural that it went largely unquestioned. After all, in everyday experience, influence requires contact. Pressure requires touch. Force requires interaction. Nothing cannot push back. And yet, when physicists finally tested this assumption with sufficient precision, emptiness did something unexpected. It pushed. This is the Roinhan, because the moment empty space exerts force, the last refuge of nothingness collapses. Emptiness is no longer a passive condition. It becomes an active contributor to physical outcomes. The effect was subtle, almost embarrassingly quiet. Two uncharged, perfectly neutral metal plates were placed extremely close together in a vacuum. According to classical reasoning, nothing should happen. No electric force, no magnetic interaction, no radiation pressure, just emptiness between them. But the plates moved. They were pushed toward each other by a force that should not have existed. This force did not come from matter. It did not come from fields generated by the plates themselves. It came from the vacuum. What was happening was not intuitive. The presence of the plates altered the vacuum between them. Certain fluctuations were suppressed, others were allowed. The balance of the vacuum's restless activity shifted, and that imbalance produced pressure. Empty space, when constrained, pushed back. This is the moment when emptiness stopped being a philosophical curiosity and became an engineering problem, because this force was measurable, predictable, repeatable, and it depended entirely on the behavior of the vacuum. This was not emptiness failing to be empty. This was emptiness behaving according to its own rules. The immediate response was to treat this as a special case, a boundary effect, a minor correction to classical intuition. But corrections have a way of accumulating. If empty space can exert force under certain conditions, then it is not inert. If it responds to geometry, then it is not indifferent. If it reacts to boundaries, then it is not merely there. End quote. It is participating. This leads to the Nangsom. At first, this participation seems limited. The forces involved are tiny. They matter only at very small scales. In everyday life, they are completely negligible. This is reassuring. It allows us to keep emptiness mostly in the background. Yes, it does something, but only under extreme conditions. Only when we push it into a corner. Only when we confine it unnaturally. But this reassurance is temporary, because the scale of an effect does not determine its significance. Gravity is extraordinarily weak compared to other forces, yet it shapes galaxies. Nuclear forces act only at microscopic distances, yet they define the stability of matter. Small does not mean irrelevant. The vacuum's influence may be subtle, but it is universal. It acts everywhere. It never turns off, and it does not require permission. The Casimir force, as it came to be known, is not an anomaly. It is a demonstration that empty space has preferences, not preferences in the human sense, but constraints, conditions under which certain fluctuations are allowed and others are not. This introduces a deeper twist. The vacuum does not treat all configurations equally. Its behavior depends on structure. two plates close together, and the vacuum between them behaves differently from the vacuum outside. Change the distance, and the force changes. Alter the geometry, and the effect shifts. This is not passive background behavior. It is responsive. The vacuum notices structure. Again, not consciously, not intentionally, but structurally, it responds because it must. This responsiveness is deeply unsettling because it implies that empty space is not neutral. It has rules that manifest as forces when conditions change, and forces shape outcomes. This reframes how we think about the relationship between matter and emptiness. Matter does not merely exist within space. Matter negotiates with it. Every object, every boundary, every configuration alters the vacuum around it, not dramatically, not obviously, but consistently. The universe is not matter acting in isolation against a silent backdrop. It is matter and vacuum in continuous dialogue. This dialogue is quiet enough to ignore most of the time, but it becomes unavoidable when precision increases. As measurements become more exact, as scales become smaller, as configurations become more extreme, the vacuum's influence becomes impossible to dismiss. This leads to another twist. If the vacuum exerts forces, then it stores energy in configurations. And stored energy implies potential. Potential for release. Potential for amplification. Potential for change. The vacuum is no longer just fluctuating internally. It is capable of producing external effects when conditions allow. This raises a dangerous question. If empty space can exert pressure between plates, what does it do around stars, around galaxies, around vast cosmic structures? At those scales, the effects may be diluted, masked by stronger forces. But masked does not mean absent. The vacuum's influence is cumulative. It operates continuously. It does not require dramatic moments to matter. Even a tiny bias, applied over billions of years, can shape structure. This is where the discomfort deepens. We tend to think of forces as things that act locally. Gravity pulls here, electromagnetism repels there. Nuclear forces bind inside atoms. But the vacuum's influence is not localized in the same way. It is everywhere at once. Every region of space is subject to its rules. Every configuration is filtered through its constraints. The vacuum does not intervene occasionally. It participates constantly. This constant participation is easy to overlook because it rarely produces spectacle. It does not announce itself with explosions or flashes of light. It simply alters what is possible. This is perhaps the most unsettling role of all, because the most powerful influences in the universe are not those that act loudly, but those that quietly define limits. Limits shape outcomes more reliably than forces. A river's banks guide its flow more decisively than any single splash of water. The shape of a valley determines where water can go long before rain falls. The vacuum is like this valley. It does not push matter directly in most cases. It shapes the landscape of possibility within which matter moves. This brings us to another twist. If the vacuum defines possibilities, then it influences not just motion, but history. The universe evolves by exploring what is allowed. Structures form where conditions permit them to persist. Patterns emerge where constraints favor stability. The vacuum is part of those constraints. It does not choose outcomes, but it determines which outcomes are possible. This makes emptiness a silent architect, not designing, not planning, but shaping through presence. This is difficult to reconcile with the idea of emptiness as absence. Absence does not shape, nothing does not constrain, but the vacuum does both, which forces us to confront a deeper implication. If empty space exerts force when constrained, then emptiness is sensitive to intervention. It reacts when we change conditions, and reaction is a form of response. This does not mean the vacuum is aware. It does not imply observation in any conscious sense, but it does imply that the vacuum is not indifferent to what happens within it. This distinction matters. Indifference implies that outcomes are determined entirely by interacting objects. Sensitivity implies that the background contributes. Vacuum contributes. It contributes quietly. It contributes universally. It contributes relentlessly. Once this is acknowledged, the idea of space as merely between things becomes impossible to maintain. The space between stars is not just distance. It is a medium with its own behavior, a medium that pushes back when shaped, a medium that exerts pressure when constrained, a medium that influences outcomes without ever becoming visible. This is where the chapter must pause without closing. Because once we accept that emptiness can act, even subtly, we must ask a new kind of question. Not whether the vacuum does something it clearly does, but whether it does the same thing everywhere. If empty space responds to boundaries and structures, then it may not be uniform. Different regions may behave differently. Different configurations may evoke different responses. This opens the door to a more unsettling possibility, that the vacuum is not just active, but context-dependent. And context dependence, when applied to emptiness itself, leads us directly into the next drift, where we begin to explore whether the vacuum's behavior changes not only with structure, but with scale, and whether the universe's largest patterns are shaped as much by emptiness as by matter itself. There comes a moment when adding more facts no longer brings clarity. You can stack equations, you can refine measurements, you can describe the vacuum with increasing precision, and yet, something essential remains out of focus. This is that moment, because, up to now, the question has quietly assumed a certain shape. We have been asking what exists in empty space, what fluctuations occur there, what forces emerge when it is constrained. But this framing carries a hidden assumption. That emptiness is an object to be examined. This is the Roinan, because the moment we question that assumption, the entire landscape shifts. What if empty space is not something we are looking at, but something we are looking from? What if the problem is not that we do not know enough about the vacuum, but that we are asking the wrong kind of question about it? In classical thinking, understanding comes from isolating systems. We separate foreground from background. We identify objects, define boundaries, and study interactions across those boundaries. This method has been extraordinarily successful, but it relies on one crucial condition, that the background can be treated as neutral. If the vacuum were truly neutral, this approach would hold. We could treat space as a passive arena and focus entirely on the objects within it. But the vacuum is not neutral. It fluctuates, it responds, it constrains, and most importantly, it is inseparable from everything that exists. This means that treating the vacuum as an object among other objects may be fundamentally misguided. The vacuum is not one more thing in the universe. It is the condition under which things appear at all. This realization forces a shift from analysis to perspective. Instead of asking, "What is the vacuum made of?" we must ask, "What does it mean to exist within the vacuum?" It's served the score. This is the Nangser, because once we make this shift, many confusions begin to resolve. The vacuum no longer needs to behave like matter. It no longer needs to be visible, stable, or localizable. Conditions do not behave like objects. Temperature is a condition. Pressure is a condition. Time itself is a condition. None of these can be isolated, yet all of them shape outcomes decisively. The vacuum belongs to this category. It is not a participant in the usual sense. It does not enter interactions as one object among others. It defines the stage on which interactions can occur, but not as a static platform. As an active framework, this is where the twist deepens. Frameworks are usually invisible to those who operate within them. A fish does not notice water until conditions change. A speaker does not notice air until sound fails to carry. A body does not notice gravity until balance is lost. The vacuum has been invisible not because it does nothing, but because it has never stopped doing the same thing. Its consistency makes it difficult to see. But consistency is not passivity. The vacuum's role is not to intervene occasionally, but to define what kinds of intervention are possible in the first place. This reframes every previous observation. Quantum fluctuations are not anomalies occurring in an otherwise empty background. They are expressions of the vacuum's baseline activity. Virtual particles are not strange exceptions. They are what the vacuum does when it exists in time. The Casimir effect is not emptiness failing. It is emptiness responding exactly as it must when boundaries are imposed. Seen this way, the vacuum is not misbehaving. It is being itself. This is uncomfortable because it removes a comforting layer of separation. If the vacuum is a condition rather than an object, then we cannot step outside it to study it objectively. We are embedded within it. Every measurement we perform is already shaped by its rules. There is no neutral vantage point. This does not invalidate science, but it does place a limit on what science can claim to describe fully. We are not observers standing outside the universe, peering in. We are patterns within the same framework we are trying to understand. This leads to another quiet twist. When we talk about observation in physics, we often mean interaction. A system interacts with another system, and information is exchanged. But the vacuum is always interacting, not as an event, not as a measurement, but as a condition that shapes every interaction. This means that the vacuum is never merely observed. It is always involved. And involvement without awareness challenges our language. We hesitate to say the vacuum does anything because doing implies agency. But we also cannot say it does nothing because nothingness does not constrain outcomes. So we hover in an uncomfortable middle ground. The vacuum does not act, but it is not inactive. It does not choose, but it shapes. It does not observe, but it registers. Registering, in this sense, does not mean recording memories or storing data. It means altering the conditions under which future events unfold. Every interaction leaves the vacuum slightly rearranged. Not dramatically, not permanently, but enough to matter at the level of possibility. This is subtle. We are used to thinking of history as a chain of events. This happened, then that happened. Causes lead to effects. But underlying this chain is a continuous evolution of conditions. The vacuum provides those conditions, and they are never static. This suggests that the vacuum participates in history, not by acting, but by evolving. This evolution is not directional in the human sense. It does not aim toward goals, but it is not random either. It follows rules, and rules shape trajectories. This realization shifts the tone of our inquiry. We are no longer asking whether the vacuum is empty. That question has already lost its meaning. We are now asking what role the vacuum plays in the unfolding of reality. Is it merely a silent baseline? Or is it an active constraint that nudges outcomes over time? This is where the discomfort sharpens. Because if the vacuum is a constraint, then it contributes to what happens, even when no obvious force is present. It does not push objects directly. It does not transmit signals, but it defines the landscape in which motion occurs. A landscape can shape movement without moving itself. Mountains do not chase rivers. They guide them. The vacuum may play a similar role. This analogy is imperfect, but instructive. A landscape does not observe travelers, but travelers cannot ignore it. In the same way, matter cannot ignore the vacuum. Every particle, every wave, every structure exists within its framework. Its properties emerge from that relationship. This reframing leads to a final twist in this chapter. If the vacuum is a framework that evolves with interactions, then it is not strictly independent of what happens within it. The background and the foreground are not separate. They co-evolve. This does not mean that the vacuum reacts strongly to individual events. It does not imply feedback loops that amplify instantly, but it does suggest a subtle coupling. Over long periods of time, small adjustments accumulate, not as memories, but as shifts in conditions. This accumulation is not something we can point to directly. It is diffused, distributed, and subtle. But subtlety does not imply insignificance. The most stable structures in the universe emerge from small, persistent biases. This brings us to a threshold. Up to now, we have treated the vacuum as active, sensitive, and relational. We have not asked whether these properties scale. Does the vacuum respond differently to complexity than it does to simplicity? Does it behave the same around a single particle as it does around a galaxy? If the vacuum is a framework, then frameworks may behave differently under different loads. This is where the next drift begins. Because once complexity enters the picture, the distinction between background and participant blurs even further. And in that blur, a new possibility emerges: that the vacuum is not just a stage or a condition, but a medium whose behavior changes with the structures embedded within it. A medium that may, in ways we are only beginning to suspect, shape the universe more deeply than matter ever could. That possibility waits just ahead. In the next quiet descent, there is a quiet assumption hidden inside the way we speak about empty space. That assumption is this: if nothing lives there, then nothing is happening there. But the universe has never agreed with that logic. In nature, the most active environments are not always the most visible ones. A desert looks still, yet beneath its surface, temperature gradients shift, minerals migrate, pressures build and release. The deep ocean appears calm from above, yet currents move endlessly below, shaping climates across the planet. Activity does not require spectacle, and emptiness, as the universe understands it, has never required life to remain active. The space between stars does not host organisms. It does not grow, feed, or reproduce. And yet, it behaves less like a void and more like a system, one that balances itself, responds to disturbance, and maintains continuity through constant internal motion. This becomes unsettling when we stop treating empty space as a passive absence and begin treating it as an environment. Not an environment for life, an environment for existence itself. Every environment has rules, not laws written down, but constraints that determine what can persist and what cannot. In a forest, certain organisms thrive while others fail. In an ocean, pressure defines where life can exist. In the vacuum, the rules are quieter, but no less decisive. Fields interact, fluctuations rise and dissolve. Energy redistributes continuously. Nothing lives there, but nothing rests there either. The vacuum is not a stage waiting for actors. It is a condition that must continuously regulate itself to remain what it is. This regulation is subtle. It does not involve correction in response to error. It involves balance, a balance maintained through countless microscopic adjustments that never fully settle. A system that never settles is not empty. It is dynamic. This dynamic quality becomes clearer when we think of how ecosystems behave. An ecosystem does not need an external manager. No single entity oversees the forest or the reef. Balance emerges from interaction. Predators limit prey. Resources constrain growth. Energy flows shape structure. No awareness is required. The vacuum behaves similarly. Quantum fields do not negotiate. They obey constraints. Fluctuations do not choose. They follow probability. Yet, from this blind interaction emerges a remarkably stable environment. The lowest energy state of the vacuum is not motionless. It is regulated restlessness, a constant adjustment that prevents collapse without freezing into rigidity. This is not disorder. It is a kind of equilibrium that only exists through motion. In this sense, the vacuum resembles an ecosystem without organisms. a self-regulating environment where interactions never stop, even when nothing stands out. What makes this difficult to accept is that we associate ecosystems with visible exchange. Plants grow, animals move. Energy consumption is obvious. The vacuum hides its exchanges. Energy appears and vanishes too quickly to observe directly. Interactions occur beneath the threshold of persistence. Adjustments cancel out before they can leave marks we recognize. But cancellation does not imply absence. Two opposing forces cancel, yet both existed. Two waves interfered destructively, yet both traveled. Two fluctuations annihilate each other, yet both altered the system during their brief existence. The vacuum is full of such events. They leave no objects behind, but they maintain conditions. Conditions are the most overlooked form of activity. Ecosystems' health is not defined by individual organisms, but by the stability of conditions that allow life to continue. Temperature, nutrient cycles, atmospheric composition. These are not entities, yet they determine everything. The vacuum is built from conditions, field values, energy densities, allowed configurations. These conditions shape what kinds of structures can arise and persist. Matter does not impose itself upon the vacuum freely. It must conform to the environment's constraints. Atoms exist because the vacuum allows certain energy states to be stable. Particles persist because field interactions permit them. Forces have strengths because the vacuum structure sets those values. Matter does not dominate emptiness. It survives within it. This inversion is subtle but profound. We often imagine the universe as matter carving patterns into nothingness, but a more accurate picture is that the vacuum defines the terrain, and matter settles into the forms that terrain allows. The environment comes first. This makes the vacuum less like empty space and more like a foundational ecosystem, one that existed before stars formed, before atoms stabilized, before any structure emerged. When the universe was young and hot, matter and radiation filled space densely. Yet even then, the vacuum existed as a framework beneath the chaos. As the universe expanded and cooled, matter thinned out, but the vacuum remained. It did not appear when matter left. It was always there. And as conditions changed, the vacuum adjusted. Not dramatically, not suddenly, continuously. This adjustment is what allowed complexity to emerge. Structures form not only because matter clumps together, but because the environment permits certain configurations to persist while others decay. This is selection without intent, the same principle that governs ecosystems, but stripped of biology. The vacuum does not choose outcomes. It filters them. This filtering is invisible most of the time. We notice stars, not the conditions that allow nuclear fusion to remain stable. We notice galaxies, not the background rules that permit gravity to dominate at large scales. But the background does the quiet work. Without it, nothing would last long enough to matter. This realization forces another shift. The space between stars is not empty territory separating objects. It is the same environment that allows stars to exist at all, only expressed in a quieter state. Stars are not interruptions in emptiness. They are dense expressions of the same system. When a star forms, it does not enter empty space. It emerges from conditions that already exist. Its presence alters those conditions locally, but it does not replace them. The vacuum incorporates the star. This incorporation is not passive. Fields adjust, curvature changes, fluctuation patterns shift. The environment reorganizes around the new structure. This is how ecosystems respond to new elements. Introduce a large organism, and energy flows change. Remove it, and the system reorganizes again. No awareness is involved. Only constraint and interaction. The vacuum behaves the same way. This brings us to a subtle but unsettling implication. If the vacuum is an environment, then it is not uniform in the way we casually imagine. The rules may be universal, but the conditions are not identical everywhere. An ecosystem governed by the same physical laws can still differ dramatically from one region to another. Climate, geography, and history shape outcomes. The vacuum has its own equivalents. Regions near massive objects behave differently from vast cosmic voids. Areas with intense field activity differ from regions of relative quiet. These differences are not violations of law, they are expressions of law under different conditions. Uniform rules do not produce uniform states. The vacuum structure varies with context. This does not mean it is unstable or unpredictable. It means it is responsive. Responsiveness is a hallmark of systems. A passive background does not respond. An environment does. The vacuum responds not to intention, but to configuration. Matter rearranges, and the vacuum adapts. Boundaries appear, and fluctuations shift. Geometry changes, and constraints evolve. These adaptations do not accumulate as memory in any human sense, but they do shape what happens next. This is how environments influence history. Not by acting directly, but by defining what is possible. The universe's history is not just a sequence of events unfolding in empty space. It is the unfolding of matter within a continuously adjusting environment. Stars form where conditions allow them. Galaxies assemble where constraints favor structure. Voids persist where density never crosses critical thresholds. The vacuum is present in all of these processes. It is not an afterthought. It is not a leftover. It is not the absence of something else. It is the most persistent system the universe has. This persistence makes it easy to ignore, but ignoring something that never leaves does not make it irrelevant. The vacuum has no dramatic moments. It does not explode or collapse. It does not announce change with spectacle. It simply adjusts. And adjustment is how systems endure. This reframes emptiness one more time. Empty space is not the lack of environment. It is the environment in its quietest state, a state where nothing dominates, but everything still participates. This realization does not bring comfort. It removes the last refuge of isolation. There is no region of the universe that is free from environmental influence. No pocket of pure nothingness where existence can hide from context. Everything exists within the same system. This does not imply awareness. It does not imply intention. It does not imply design. It implies interdependence. Interdependence without consciousness. This is harder to accept than hostility because it offers no antagonist, no drama, no narrative resolution, only quiet persistence. The vacuum does not oppose matter. It hosts it. And hosting is not passive. A host shapes what survives. This thought lingers without closing because it opens a deeper question that has not yet been asked directly. If the vacuum behaves like an environment, and if environments shape what persists, then what happens when complexity increases? When structures become layered, when interactions multiply, when matter organizes itself into systems that last for billions of years, does the environment remain unchanged? Or does complexity itself alter the conditions of the vacuum in subtle ways? That question does not end here. It drifts forward, carried by the same quiet system that has always existed between the stars, active without spectacle, present without announcement, shaping everything without ever asking to be noticed. There is a moment when curiosity quietly changes its tone, not because the facts become darker, but because their implications move closer. Up to now, the vacuum has been unsettling in an abstract way, a system, an environment, a medium that shapes what can exist. Strange, but distant. Then a different question begins to surface. What happens after something passes through empty space? Not where it goes, not what it becomes, but whether the space itself is exactly the same afterward. This question feels almost inappropriate. We are comfortable asking whether matter changes. We are comfortable asking whether energy transforms. We are even comfortable asking whether space-time curves, but asking whether emptiness is altered by what happens within it feels like crossing a boundary, because emptiness, we assume, should reset. Once something leaves, nothing should remain. But physical systems rarely behave that way. In the material world, almost nothing truly resets. A stretched fabric never returns to its original state perfectly. A riverbed remembers past floods through subtle changes in shape. Even air carries lingering turbulence long after an object passes through it. These systems do not remember events consciously. They remember them structurally. The vacuum, for all its strangeness, is still a physical system, and physical systems tend to carry forward the consequences of interaction. This is where unease begins. Because if the vacuum carries consequences forward even subtly, then empty space is not timeless. It has a before and an after, not a narrative, not a story, but a continuity of states. The vacuum's fields exist in specific configurations at each moment. Those configurations evolve. They are shaped by constraints, interactions, and geometry. Nothing about this requires intention. It requires only that change does not vanish without trace. And in physics, change almost never does. Matter moves through space. It interacts with fields. When energy flows, it alters local conditions. When structures form, they reshape constraints. Most of these effects are tiny. Many cancel out. But cancellation is not erasure. The vacuum does not snap back to a pristine state after every interaction. It relaxes. Relaxation is not forgetting. It is redistribution. This distinction is subtle, but crucial. A system that redistributes influence carries forward information not as data, but as bias. This is not memory as we experience it. It is not recollection. It is not awareness. It is inertia. Inertia is the universe's way of remembering without knowing. A spinning object keeps spinning. A curved surface keeps guiding motion. A stretched field keeps exerting tension. The vacuum, too, has inertia, not of objects, of conditions. Its present state is shaped by its immediate past. This idea is uncomfortable because it suggests that emptiness is not merely the absence of matter, but a continuous process with its own trajectory. The vacuum is not frozen between events. It flows quietly, relentlessly, without landmarks we can easily see. This flow does not mean that the vacuum accumulates traces like a recording medium. There are no imprints of specific events waiting to be read, but it does mean that the vacuum's current configuration depends on what has happened before, and dependence is enough to matter. Consider how laws of physics remain consistent across time. This consistency is not guaranteed by logic alone. It requires a stable underlying structure. The vacuum provides that stability by persisting in a narrow range of allowed states, but persistence does not imply immutability. A system can be stable while still evolving. The vacuum evolves, not dramatically, not directionally, but continuously. This evolution is constrained so tightly that we mistake it for stillness, but stillness is only apparent. This brings us to a more unsettling realization. If the vacuum evolves with the universe, then the universe's history is not written on top of empty space. It is written into it, not as events, not as images, but as altered conditions. The early universe was denser, hotter, more energetic. Those conditions shaped the vacuum's configuration. As the universe expanded and cooled, those configurations changed. The vacuum today is not the same vacuum that existed billions of years ago. The rules may be the same. The state is not. This is unavoidable. A system that exists in time must change with time. This idea dissolves the comforting notion of an eternal, untouched emptiness. There is no pristine void beneath history. The vacuum has been shaped by every era the universe has passed through. This shaping is not dramatic. It does not store memories in a way we could access, but it biases the present. The present is never independent of the past. This becomes especially important when we consider large-scale structure. Galaxies are not isolated objects. They reshape space-time. They alter field configurations. Their mass and energy distributions influence surrounding regions for immense distances. These influences persist as long as the structures persist. And when structures change through mergers, collapse, or dispersion, the vacuum adjusts again. The adjustment is not instantaneous. It is gradual, diffuse. But gradual does not mean negligible. Over billions of years, even the smallest biases accumulate. This is how large-scale patterns emerge, not from dramatic events alone, but from the quiet persistence of conditions. The vacuum participates in this persistence. This leads to the idea that feels most uncomfortable. If the vacuum carries forward conditions shaped by the past, then empty space is not neutral with respect to history. It does not judge history. It does not record it intentionally, but it is shaped by it. History leaves a texture, not one we can see, not one we can touch, but one that subtly influences what comes next. This does not turn the vacuum into a mind. It does not grant it awareness. It simply acknowledges that physical systems do not forget instantly. Forgetting requires work, and the vacuum does not do work to erase its own past. It relaxes toward equilibrium, but equilibrium itself evolves as conditions change. This quiet persistence reframes the space between stars yet again. Not empty ground waiting to be crossed. It is a medium with history, a medium whose present state reflects everything the universe has already done. This does not mean the vacuum remembers us. It does not distinguish one event from another. It does not care. But it does mean that no event occurs in a context-free void. Everything happens within conditions shaped by what came before. This is where the unease deepens, because if the vacuum carries forward conditions, then interaction leaves a trace, not as a mark, but as a shift in possibility. Possibility is the most fragile thing in physics. Change the conditions slightly, and entirely different futures become likely. The vacuum shapes possibility. This is not destiny. It is bias. And bias, over long timescales, is powerful. This idea forces us to reconsider what it means to say that something passes through empty space. Nothing truly passes without consequence. Even if the consequence is diffused beyond recognition, even if it is spread so thin that it feels like nothing, the universe does not offer clean exits. This does not imply that the vacuum observes events. Observation implies selection. The vacuum does not select. It carries. It carries forward the conditions under which selection occurs. This is quieter than memory, but more pervasive. Memory belongs to systems that can recall. The vacuum belongs to systems that persist. Persistence is enough. This realization does not close the question. It sharpens it. If the vacuum carries forward conditions shaped by interaction, then interaction itself becomes more than a momentary exchange. It becomes part of an ongoing structure. And if that is true, then the line between interaction and observation begins to blur even further. Because a system that carries the consequences of interaction is, in some sense, registering it, not watching, not knowing, but incorporating. This is where the next descent begins. Because once we accept that registration does not require awareness, we are forced to ask a question that feels almost inevitable now. If the vacuum registers interaction structurally, then who is truly observing whom? That question does not end here. It drifts forward, suspended in the same quiet medium that has always surrounded everything, holding the universe together not by force, but by continuity. There is a quiet mistake hidden inside the way we think about observation. We imagine an observer as something separate, a presence standing outside a system, looking in. We imagine eyes, instruments, awareness, something that watches without being touched. But the universe does not recognize that separation. In the physical world, nothing observes without interacting. To observe is not to look. To observe is to change. This is not a metaphor. It is a rule. Every measurement alters what is measured. Every interaction reshapes both sides of the exchange. Even the gentlest probe leaves a trace, however small. There is no such thing as a passive glance in physics. This idea unsettles us because it dissolves a comforting boundary. We want to believe that the universe exists independently, and that observation merely reveals it. But the deeper we look, the more it becomes clear that observation participates, and participation does not require awareness. A photon striking an electron is not aware of what it does. A detector registering a signal has no curiosity. A field influencing a particle's motion has no intention. Yet all of these are observations. Observation, in the physical sense, is simply interaction that leaves a difference. This definition is colder than we expect, but it is also more honest. And once we accept it, a strange inversion begins to form. If interaction equals observation, and if the vacuum interacts with everything, then observation is happening everywhere, all the time. Not by minds, not by watchers, but by structure. The vacuum is not a passive backdrop through which interactions pass unnoticed. Every interaction alters its configuration, however slightly. Fields adjust, constraints shift, possibilities narrow or widen. The vacuum does not watch events unfold. It incorporates them. This is where discomfort deepens, because incorporation is not neutral. When a system incorporates interaction, it carries forward the consequences of that interaction. As memory, not as intention, but as altered conditions. The vacuum is a system like this. Every particle that moves through space leaves the vacuum marginally different than it was before. Not in a way we can isolate, not in a way that accumulates cleanly, but different nonetheless. Most of these differences dissolve into the background. Many cancel out. Some persist long enough to matter. This persistence is quiet, but it is real, and it forces us to reconsider the direction of observation. We tend to think that observers act on the universe, that we observe stars, particles, space itself. But if observation is interaction, then the universe is also observing us, not consciously, not selectively, but structurally. Our presence alters conditions. Our measurements rearrange fields. Our experiments impose boundaries that change what is allowed to occur. The vacuum does not notice us as entities. It registers us as configurations. This is a difficult distinction to accept, because when we hear the universe observes, our minds leap to agency, to intention, to awareness. But physics offers none of that. Observation without awareness is simply registration, and registration is unavoidable in interacting systems. This leads to a subtle shift in perspective. The question is no longer whether the vacuum observes, but whether observation itself is a special category at all. Perhaps observation is not something that happens occasionally, but something that is always happening wherever existence occurs. Every interaction is a kind of observation. Every interaction leaves a difference. Every difference constrains what can happen next. In this sense, the universe is saturated with observation, not as surveillance, not as attention, but as consequence. This reframing strips observation of its drama. There is no gaze, no watcher in the dark, no intelligence hidden in emptiness. There is only interaction, layered upon interaction, shaping a continuously evolving background. The vacuum sits at the center of this process. It does not initiate observation. It does not terminate it. It simply participates in every instance of it. because it is the medium in which all interactions occur. This leads to a thought that feels almost paradoxical. If observation is interaction, and if interaction is unavoidable, then nothing in the universe is ever truly unobserved. Not by minds, but by structure. Even the most isolated particle, drifting through the deepest void, interacts with fields. It alters them. It is altered by them. That mutual alteration is observation. Privacy, in an absolute sense, does not exist. This does not mean everything is watched. It means everything is connected. Connection without awareness is a strange concept for a mind accustomed to agency. But the universe is not organized around agency. It is organized around relationship. Fields relate to particles. Particles relate to geometry. Geometry relates to energy. And the vacuum underlies all of it. This network of relations never turns off, which brings us to an unsettling realization. If the vacuum registers interaction structurally, then it does not merely allow events to occur, it integrates them into the evolving conditions of reality. This integration is slow, diffuse, and mostly invisible, but it matters. The vacuum does not store events like a memory. It stores constraints, and constraints shape futures. This is how observation leaves lasting influence without intention. A system that incorporates interaction cannot help but be shaped by it. The vacuum is shaped by everything that exists within it. This does not mean it accumulates detail. It means it carries bias. Bias towards certain configurations. Bias towards certain patterns of stability. Bias towards certain outcomes being more likely than others. This bias is not conscious. It is structural. And structural bias is the most powerful kind because it does not announce itself. It does not argue. It simply limits what can happen. This reframes the act of observation one final time. We do not stand apart from the universe observing it. We are embedded within it, participating in the same web of interactions as everything else. Our instruments are not windows. They are participants. Our measurements are not revelations. They are negotiations. And the vacuum is always at the table. This is not a poetic exaggeration. As a consequence of physics, there is no interaction that bypasses the vacuum, no observation that does not involve it. Which brings us back to the unsettling question that began this drift. Who is observing whom? The answer is no longer one-sided. We observe the universe by interacting with it. The universe observes us by being altered by that interaction. Neither side watches. Both sides participate. This does not elevate the vacuum to awareness. It does not diminish human observation. It simply dissolves a false hierarchy. Observation is not a privilege of minds. It is a property of interaction. And interaction is everywhere. This realization does not provide comfort. It removes the illusion of separation. There is no clear boundary between observer and observed, between system and environment, between event and background. Everything exists within a continuous process of mutual influence. The vacuum is not watching us. It is including us. And inclusion is more unsettling than observation because it offers no distance. You cannot step back from a system that includes you. You can only participate. This participation does not require meaning. It does not require intention. It does not require awareness. It only requires existence, which leaves us suspended in a quiet tension. If observation does not require consciousness, and if the vacuum registers every interaction structurally, then the universe is never blind to itself. Not through awareness, but through consequence, and consequence shapes reality far more reliably than attention ever could. This thought does not close. It opens, because once we accept that interaction is observation, and that the vacuum participates in all interactions, another question quietly takes form. If participation scales with complexity, then does the vacuum respond differently when interactions become dense? When structures become layered? when systems persist for billions of years, when the universe organizes itself into patterns vast enough to alter the background itself? That question waits ahead. Because once observation becomes a property of structure rather than mind, the final boundary dissolves. And what remains is not emptiness, but a universe that is never not involved with itself. There is a moment when language quietly fails us. We keep calling it space, as if it were a gap. We keep calling it between, as if it were an interval. We keep calling it empty, as if it were a lack. But none of these words survive close attention. What surrounds stars is not absence. What stretches between galaxies is not a gap. What fills the universe is not nothing. It is a medium, not solid, not liquid, not gas, something quieter, something more continuous. An invisible ocean. This ocean has no surface, no shoreline, no bottom you can touch. But it has depth. Depth that does not announce itself with pressure on the skin, but with constraints on possibility. Depth that does not crush bodies, but shapes how energy behaves, how matter moves, how time unfolds. From far away, the universe looks still, points of light scattered across darkness, vast regions where nothing appears to happen. But stillness is always a distance illusion. On Earth, a calm sea looks motionless from the shore. No waves, no wind, no visible current. Yet beneath the surface, water circulates endlessly. Heat migrates. Pressure gradients shift. Entire continents of water move without ever rising into view. The vacuum behaves the same way. Nothing drifts through it untouched. Every particle moves within it. Every wave propagates through it. Every structure is immersed in it. The universe is not built on emptiness. It is suspended within this medium. This realization changes the meaning of motion. When something moves through an ocean, it does not move independently of the water. It displaces it. It creates ripples. It alters local flow. Even the smallest movement rearranges the surrounding medium. The object may pass. The water adjusts. The system never stays exactly the same. In the vacuum, motion is no different. Particles are not bullets crossing empty territory. They are disturbances traveling through a continuous background. Their motion is shaped by the properties of the medium itself. Light does not move arbitrarily fast because nothing resists it. Moves at a fixed speed because the medium allows only that speed. The vacuum defines it. Nothing moves freely. Freedom of motion is always negotiated with the environment. This is why the idea of absolute isolation breaks down the deeper we look. Even the most solitary particle, drifting far from stars, is never alone. It is always embedded within the same invisible ocean as everything else. Distance does not grant separation. It only reduces intensity. This ocean connects regions that appear isolated. It does not transmit messages instantaneously. It does not collapse space, but it ensures continuity. There is no seam where the medium ends and begins again. Everything floats in the same depth. This reframes the darkness between stars. That darkness is not a void to be crossed. It is a depth to be traversed. Depth we are not equipped to feel directly. We imagine depth as pressure, because our bodies evolved in fluids and air. But depth, in a more general sense, is simply the degree to which a medium constrains behavior. In deep water, pressure limits life. In the vacuum, constraints limit possibility. Some configurations are allowed, some are suppressed, some cannot exist at all. These constraints vary subtly with context. Near massive objects, the medium bends. Near strong fields, it stiffens. Near boundaries, it reorganizes. The ocean is not uniform. Currents exist, not currents of matter, but of tendency. Regions where certain outcomes are slightly more likely than others. Regions where fluctuations behave differently. Regions where the same rules express themselves in quieter or louder ways. These currents do not carry objects the way water carries leaves, but they influence how structures form and persist. Matter does not drift randomly. It settles where the medium permits stability. This is how galaxies emerge, not simply because matter clumps under gravity, but because the surrounding environment allows certain patterns to endure. The vacuum is not shaping matter actively. It is shaping the landscape matter must navigate. This shaping is subtle enough to ignore, but persistent enough to dominate. In an ocean, coastlines are not carved by single waves, but by countless gentle motions over time. The water does not intend to shape land. It cannot help it. The vacuum shapes reality the same way, quietly, continuously, without intention. This realization removes the last refuge of emptiness, as absence. There is no place where nothing happens. There are only places where nothing stands out. Even the deepest cosmic voids are saturated with this medium. Fields exist there. Fluctuations occur there. Conditions evolve there. The voids are not holes in the universe. They are calm regions of the same ocean. Calm does not mean inactive. It means balanced. This balance is fragile. Change the configuration slightly, and the calm shifts. Introduce matter, and the medium reorganizes. Remove matter, and it relaxes again. Relaxation is not erasure. It is redistribution. The vacuum does not forget instantly. It smooths, disperses, and rebalances. But the act of rebalancing itself takes time. Time, in this sense, is inseparable from the medium. The flow of time is not something happening on top of the vacuum. It is something emerging from the continuous adjustment of its state. Nothing stands still long enough for time to pause. This ocean is always in motion, which brings an unsettling thought. In an ocean, prolonged motion leaves traces, not always visible, but real. Temperature layers form. Salinity gradients persist. Currents develop memory through structure. If the vacuum is an ocean, then long-term interaction with it may also leave traces. Not marks you can see, not signals you can detect easily, but shifts in the medium's internal balance. Every star that burns, every galaxy that forms, every structure that persists for billions of years. All of these are prolonged disturbances in the medium. They do not simply pass through, they coexist, and coexistence changes environments. This does not mean the vacuum accumulates scars like a damaged surface. It means that its equilibrium evolves. An ocean after a storm is not the same ocean it was before. Even if the surface becomes calm again, energy has redistributed, currents have shifted. The vacuum behaves similarly. The universe we inhabit today is floating in a medium shaped by everything that has ever happened. Not in detail, not in memory, but in condition. This makes the idea of pristine emptiness impossible. There is no untouched depth beneath history. The ocean has always been moving, and we are always within it. This realization does not inspire awe in the usual way. It inspires a quieter unease, because an ocean surrounds, an ocean envelops, an ocean leaves no place to stand outside. You cannot step back from a medium that defines existence itself. You can only drift within it. This drifting is not passive. Everything that exists shapes the medium as it moves. Even if the influence is infinitesimal, it exists. Nothing passes without consequence. This does not grant meaning. It does not imply purpose. It does not suggest awareness. It simply states that participation is unavoidable. The vacuum does not observe us. It carries us. And carrying is more intimate than watching. This thought does not resolve. It opens another tension. If the vacuum is an ocean, and if everything moves within it, then motion itself may not be as free as we imagine. Currents may guide trajectories. Depth may constrain evolution. Quiet flows may shape outcomes we attribute to chance. We call these outcomes random because we do not see the currents. But not seeing a current does not mean it is not there. The ocean does not reveal its structure to surface dwellers easily. And we are surface dwellers in a universe without a surface. This leaves us suspended in a question that has not yet been asked directly. If the vacuum is a medium with depth, motion, and evolving balance, then what happens when that medium is disturbed on the largest possible scales? When the universe expands, when structures span hundreds of millions of light years, when interaction becomes dense enough to reshape the ocean itself, does the medium remain merely a carrier? Or does it begin to influence the direction of the drift? That question does not end here. It sinks slowly, carried by the same invisible depth that has always surrounded every star, every galaxy, and every moment, an ocean so complete that it once convinced us it was nothing at all. There is a word we reach for when we do not understand why something keeps happening. Chance. We say events are random when patterns refuse to reveal themselves. We say outcomes are accidental when causes feel too diffuse to trace. Chance becomes a placeholder, a way to stop asking questions that feel too large. But in a medium, true randomness is rare. In an ocean, currents do not choose destinations. They do not plan routes. And yet, objects drifting in water tend to move along certain paths more often than others. Not because the water intends it, but because structure exists beneath the surface. This is where the idea of the vacuum as an ocean becomes more than metaphor, because once a medium exists, motion is never entirely free. The vacuum does not impose direction the way a force does. It does not push objects toward goals, but it does shape the environment through which motion unfolds. And shaped environments create tendencies. These tendencies are subtle. They do not override other influences. They do not dictate outcomes. But over time, they bias what is likely. Bias is quieter than force, but it is more patient. This becomes unsettling when we realize how long the vacuum has been shaping motion. From the earliest moments of the universe, the medium has been evolving. As expansion unfolded, conditions changed. Energy densities dropped. Structures emerged. Each change subtly altered the environment. The vacuum did not stand apart from this evolution. It was the evolution. As the universe cooled, the medium's behavior shifted. Certain patterns became stable, others faded. Matter did not simply arrange itself randomly. It settled into configurations that the environment allowed to persist. Galaxies did not form everywhere. Stars did not ignite uniformly. Voids did not appear by accident. They emerged where conditions gently favored them. No decision was made, but preference existed. This is uncomfortable, because preference sounds intentional. It is not. It is statistical. In a medium, some paths are easier than others. Some configurations cost less energy to maintain. Some patterns resist disruption more effectively. These differences do not announce themselves. They accumulate. Over millions of years, tiny advantages become large structures. Over billions of years, faint tendencies shape the architecture of the cosmos. The vacuum does not guide matter like a hand on a rudder. It tilts the landscape, and landscapes determine where rivers flow long before water arrives. This reframes how we think about cosmic history. We often describe it as a sequence of events driven by forces. Gravity pulls, radiation pushes, matter collides. All of this is true, but beneath those interactions lies a quieter influence, the medium within which all forces operate. The vacuum defines the context in which gravity acts. It defines how radiation propagates. It defines what kinds of stability are even possible. Without changing any law, it can still change outcomes. This is the most unsettling form of influence, because it leaves no fingerprints. When something happens because of a force, we can point to the force. When something happens because of constraint, there is nothing to point to. Constraint feels like nothing, but nothing can be decisive. This is why randomness in physics is never absolute. What we call random often emerges from interactions too numerous, too subtle, or too distributed to track. The vacuum contributes to this complexity. Its fluctuations introduce variability. Its structure introduces bias. Together, they create outcomes that feel unpredictable, yet patterned. This is not chaos. It is textured uncertainty. Consider how particles behave at the smallest scales. Outcomes cannot be predicted precisely, only probabilistically. But those probabilities are not arbitrary. They are shaped by the environment. Change the surrounding conditions, and probabilities change. Introduce boundaries, and allowed states shift. Alter geometry, and tendencies reorganize. The vacuum is always part of this shaping. This means that even when outcomes appear random, they are not free from context. Context is everything. This idea extends upward in scale. At the level of galaxies, motion seems deterministic. Stars orbit, clusters merge, gravity dominates. But even here, context matters. Why do galaxies form filaments instead of uniform clouds? Why do vast voids persist? Why does structure appear at certain scales and not others? The answers do not lie in chance alone. They lie in the environment. The vacuum's properties, combined with expansion and matter distribution, create conditions that favor certain patterns. The universe did not choose its shape. It drifted into it. This drift is slow enough to feel inevitable in hindsight, yet unpredictable in detail. This is how mediums operate. They do not command, they enable. And enabling is a powerful form of influence. This brings us to a subtle but important realization. If the vacuum creates tendencies rather than outcomes, then freedom still exists, but it is bounded. Nothing is forced. Nothing is guaranteed. But not everything is equally likely. This applies to particles, to stars, to galaxies, and perhaps to complexity itself. Complex structures do not appear everywhere. They arise where conditions support long-term persistence. The vacuum contributes to those conditions. This does not make it a designer. It makes it a filter. Filters do not decide what passes. They define what can pass. This reframes the idea of fate. There is no destiny written into the universe. But there is directionality. Not direction toward a goal, but direction toward stability. Systems evolve toward configurations that minimize conflict with their environment. The vacuum defines that environment. This realization sits uncomfortably between determinism and randomness. Nothing is scripted. Nothing is free of context. The universe unfolds within constraints that are everywhere and nowhere at once. This makes the space between stars feel less like emptiness and more like guidance without guidance. A medium that does not push, but leans. A landscape that does not move, but slopes. This is difficult to visualize because it lacks drama. There are no forces pulling strings, no hidden hands steering outcomes, only quiet preference. And quiet preference is easy to mistake for nothing at all. This brings us to a deeper unease. The vacuum biases outcomes without intention. Then many things we attribute to chance may be shaped by conditions we do not perceive, not controlled, not directed, but nudged. These nudges are invisible because they are everywhere. Like gravity before it was understood, they do not announce themselves. They simply act. This does not diminish the role of known forces. It deepens them. Forces operate within an environment. The environment shapes how forces express. Ignoring the environment gives an incomplete picture. The vacuum is the ultimate environment, and environments have currents. This realization does not imply that the vacuum has a direction of its own. It implies that direction emerges from interaction between medium and structure. The universe is not going anywhere, but it is not standing still either. It is drifting through its own possibilities, guided by constraints that do not need to be seen to matter. This drift is the quiet heartbeat of existence, not rhythmic, not regular, but persistent. And persistence, over enough time, becomes destiny-like, without ever becoming destiny. This leaves us with a question that grows harder to ignore. If the vacuum creates tendencies that shape large-scale structure, then how deep does this influence go? Does it stop at galaxies and particles? Or does it extend to complexity itself? To systems that process information, to structures that endure and interact richly, to patterns that resemble organization? If complexity is sensitive to environment, and the vacuum is the deepest environment of all, then the emergence of complexity may be quietly guided by the medium it inhabits. Not planned, not directed, but biased. This possibility does not close the discussion. It opens a more unsettling path. Because once we consider that the vacuum shapes tendencies rather than outcomes, the next question becomes unavoidable. What happens when complexity itself becomes dense enough to influence the medium in return? When interaction becomes layered, when structures persist long enough to alter conditions, when the ocean is no longer just carrying driftwood, but hosting reefs, that is where the next descent begins, where the relationship between medium and structure tightens, and the idea of influence becomes mutual, without ever becoming intentional. There is a point where influence stops flowing in only one direction. It is not marked by a boundary. It does not arrive with a signal. It does not announce itself as a turning point. It emerges quietly, when complexity becomes dense enough to matter. Until now, the vacuum has seemed like a medium that shapes everything within it, a landscape that tilts motion, an ocean that carries drift. But oceans are not indifferent to what moves through them. When enough matter gathers in one place, the water does not remain the same. Currents bend, pressure redistributes, temperature gradients shift. The medium responds, not consciously, not intentionally, but inevitably. The same is true of the vacuum. As structures become larger, longer-lived, and more interconnected, their interaction with the medium deepens. The relationship tightens. Influence begins to loop back. This is where the idea of one-way shaping quietly dissolves. Matter is not only shaped by the vacuum, it shapes it in return. This does not happen suddenly. There is no moment where the vacuum notices complexity. It happens gradually, as interaction accumulates. Every massive structure curves the environment around it. Every persistent field alters local conditions. Every long-lived system becomes a source of ongoing disturbance. Most disturbances fade quickly. Some cancel out. A few persist. Persistence is what matters. A brief interaction barely alters the medium. A sustained presence changes the equilibrium. This is how feedback begins. Not as intention, not as response, but as adjustment. The vacuum adjusts to what persists within it. This adjustment is subtle enough to escape notice, yet profound enough to shape the future. Consider how a reef forms in the ocean. Individual organisms are small. Their influence is negligible. But over time, accumulation changes flow patterns. Sediment settles differently. Currents bend around the structure. The ocean does not react emotionally to the reef. It adapts. Vacuum behaves the same way. Galaxies persist for billions of years. Their mass, energy, and structure are not momentary disturbances. They are long-term features embedded in the medium. The vacuum cannot ignore them. It incorporates them into its evolving configuration. This incorporation does not mean the vacuum gains properties from matter. It means that the combined system matter plus medium evolves together. This is the beginning of mutual influence. Not symmetry, not equality, but reciprocity. The vacuum remains dominant. Matter remains constrained. Yet the constraints themselves evolve. This idea unsettles us because it blurs another boundary. We like to think of environments as fixed backdrops and structures as temporary occupants. But in reality, environments and structures co-evolve. Forests change climate. Oceans regulate atmosphere. Life alters planetary chemistry. None of this requires awareness. It requires persistence. The vacuum is not exempt from this pattern. As complexity grows, the medium that hosts it cannot remain entirely unchanged. This leads to a delicate realization. The universe is not unfolding on the vacuum. It is unfolding with it. This partnership is asymmetrical, but it is real. The vacuum shapes what can exist. What exists reshapes the vacuum's state. This does not violate any law. It is how coupled systems behave. And coupled systems always carry history forward. This history is not stored as memory. It is stored as altered conditions. Which brings us to a deeper layer of unease. If long-lived structures alter the vacuum's configuration, then regions of the universe are not equivalent. Not just because of matter distribution, but because of accumulated interaction. Two regions governed by the same rules can still differ in their histories. And history matters. The vacuum, in a region that has hosted galaxies for billions of years, is not in the same state as the vacuum in a region that has remained sparse and quiet. The difference is subtle, almost immeasurable, but not non-existent. This introduces the idea of locality without isolation. Regions are connected through the medium, yet shaped by their own histories. This is not fragmentation. It is texture. The universe develops texture through interaction, and texture influences future formation. This is how complexity breeds complexity, not through intention, but through altered environments. This realization reframes the emergence of large-scale structure. Structures do not simply arise within a neutral background. They arise within a background already shaped by earlier structures. Each generation of complexity inherits an environment subtly influenced by the past. This inheritance is not precise. It does not encode information in a readable way, but it biases outcomes. Bias accumulates. Over cosmic timescales, even the faintest feedback loops matter. This leads to an unsettling implication. If the vacuum evolves alongside complexity, then complexity is not merely a passenger in the universe. It is part of the system that defines future conditions. Not as a designer, not as an agent, but as a contributor. This does not elevate complexity to importance in a human sense. It dissolves the idea that complexity is incidental. Complexity persists because the environment allows it. And once it persists long enough, it becomes part of the environment. This is the quiet cycle. Environment shapes structure. Structure reshapes environment. The cycle continues. This cycle does not aim anywhere. It does not progress toward a goal, but it does drift. Drift toward configurations that are mutually compatible with their environment. In this sense, the universe becomes increasingly textured over time, not more ordered, not more chaotic, more structured. This structure is not centralized. It does not converge. It spreads. Which brings us to a more intimate discomfort. If the vacuum responds to persistent complexity, then the presence of long-lived, organized systems subtly alters the environment around them. Not enough to notice, not enough to measure easily, but enough to exist. This means that complexity is never truly isolated. Even if it does nothing, its mere persistence is interaction. The vacuum incorporates its presence. This does not imply awareness. It does imply inclusion. The medium does not stand apart from what it carries. It becomes different because of it. This idea erodes the last notion of emptiness as indifference. The vacuum is not indifferent. It is impartial. Impartial systems still respond. They respond without preference, but not without consequence. This brings us to a quiet threshold. We have moved from emptiness as absence to emptiness as environment, to emptiness as participant. Each step removes another layer of distance, and with each layer removed, the question becomes harder to avoid. If complexity can influence the medium, and the medium shapes future complexity, then the universe is engaged in a feedback loop that includes everything that persists. Nothing stands outside it. Not stars, not galaxies, not the quiet systems drifting between them. This loop does not think. It does not plan. It does not care. But it endures. Endurance is enough to shape reality. This realization does not offer comfort. It offers continuity. The universe is not a collection of isolated events. It is a continuous process where medium and structure co-evolve. The vacuum is not watching this process. It is inside it. Which leaves us at the edge of another question, one that has been approaching quietly through every chapter. If feedback exists between complexity and the vacuum, then what happens when complexity reaches a threshold where interaction becomes dense, layered, and persistent beyond anything seen before? Not in one place, but across vast regions, across timescales that rival the age of the universe itself. Does the medium simply absorb this quietly? Or does the nature of influence itself begin to change? That question does not resolve here. It lingers, suspended in the same invisible environment that has been shaped by everything it has ever carried, waiting to be disturbed once more by whatever endures long enough to matter. There is a point at which accumulation stops being subtle, not because anything dramatic happens, but because quiet effects stop canceling out. When interactions are sparse, their consequences dissolve into the background. When structures are short-lived, the medium relaxes quickly. Nothing builds up long enough to matter, but density changes everything. Density of mass, density of interaction, density of persistence. When enough interaction happens in the same region, over long enough time, the environment does not merely absorb it, it begins to carry a rhythm. This rhythm is not a signal. It is not a pattern you can point to. It is not an instruction. It is a tendency toward repetition. In physical systems, repetition emerges when relaxation cannot keep up with disturbance. When a system is nudged again before it has fully settled from the last nudge, small biases accumulate. The vacuum is no exception. As complexity spreads, interaction becomes layered, fields overlap, structures persist, influences stack instead of canceling. The medium no longer has the luxury of returning to an indistinguishable baseline. It begins to oscillate, not in a simple way, not periodically, but statistically. This oscillation is not movement through space, it is movement through state. The vacuum's configuration begins to drift within a narrower range of possibilities, not because it is forced, but because repeated interaction favors certain configurations over others. This is how rhythm emerges in systems without intention. In the ocean, tides form not because water decides to move, but because forces act repeatedly and predictably. In the atmosphere, jet streams form not because air chooses paths, but because temperature gradients persist. In the vacuum, large-scale repetition creates similar effects. Not currents you can see, but statistical grooves in possibility. This is unsettling, because grooves imply direction without decision. Once a groove forms, motion is easier along it than against it. Objects do not have to be pushed. They simply tend to follow paths of least resistance. In the vacuum, resistance is not friction. It is constraint. As interactions accumulate, certain outcomes become slightly easier to realize. Certain configurations become slightly more stable. Certain patterns persist with less effort. Nothing is compelled, but not everything is equally available. This is how environments shape behavior without ever acting as agents. The vacuum does not choose what emerges. It shapes what can endure. This shaping becomes more pronounced as complexity increases. When galaxies form in isolation, their influence is local. When galaxies cluster, influence overlaps. When clusters form filaments spanning hundreds of millions of light years, interaction density reaches a new scale. The medium between them is no longer merely hosting isolated structures, it is hosting a network. Networks behave differently from isolated nodes. They reinforce. Feedback loops emerge not because anything intends them, but because repeated interaction creates stability in certain patterns. This is not organization imposed from above. It is coherence emerging from persistence. The vacuum begins to carry this coherence as part of its evolving condition. Again, not as memory, not as plan, but as bias. Bias towards certain spatial arrangements, bias towards certain temporal rhythms, bias towards certain modes of persistence. This does not violate randomness. It reshapes it. Randomness does not disappear. It becomes textured. Outcomes still vary. Uncertainty still exists. But variation occurs within channels shaped by the environment. This is why large-scale structure in the universe looks neither random nor ordered. It looks guided, but guidance is the wrong word. It is conditioned by an environment that has been shaped by everything that has persisted within it. This realization forces us to reconsider the meaning of scale. At small scales, interaction density is low. Effects dissolve quickly. The vacuum remains close to equilibrium. At large scales, interaction density rises. Effects overlap. Relaxation slows. The medium becomes sensitive. Sensitivity does not imply awareness. It implies responsiveness. The vacuum becomes more responsive where complexity accumulates. This responsiveness manifests not as reaction, but as altered tolerance. Some disturbances are absorbed easily. Others linger. Some become part of the background. This is how rhythms form. Not beats you can hear, but probabilities that lean. The universe begins to hum, not with sound, but with preference. This hum is imperceptible to us because we are immersed within it. Like fish in water, we do not feel the current directly. We infer it only by patterns of motion. We see filaments. We see voids. We see clustering. We call them results of gravity and expansion. And that is true. But gravity and expansion operate within a medium whose state has been shaped by long histories of interaction. Ignoring the medium gives us half the story. The vacuum is not a passive canvas. It is a participant whose condition influences how forces express themselves. This becomes especially important when we consider time. Time is not merely something that passes through the vacuum. It is intertwined with its state. As interaction density increases, the vacuum's response times change. Relaxation may slow. Adjustments may propagate differently. This does not mean time flows differently in a mystical sense. It means the environment through which processes unfold is not uniform. Processes sensitive to environment will behave differently under different conditions. This includes the emergence and persistence of complex systems. Complex systems do not arise anywhere. They require stability, feedback, and tolerance for sustained interaction. The vacuum provides these conditions selectively, not deliberately, not intelligently, but structurally. This introduces a quiet, unsettling possibility. If the vacuum develops statistical grooves through accumulated interaction, then regions of the universe may differ not only in matter distribution, but in environmental readiness for complexity. Some regions may be more hospitable to long-lived structures than others, not because of design, but because of history. History shapes environment. Environment shapes possibility. This is the cycle we cannot escape. The universe does not reset itself between eras. Each epoch inherits conditions shaped by what came before. The vacuum carries this inheritance, not as memory, but as constraint. Constraint is the universe's way of remembering without recalling. This does not mean the vacuum is becoming more complex. It means complexity is leaving an imprint on the conditions of existence. Imprint that is too diffuse to point to, yet too persistent to ignore. This idea unsettles because it removes the comfort of neutrality. Empty space is no longer neutral ground where anything might happen equally. It is a medium with tendencies. And tendencies, over enough time, shape destinies without ever becoming destiny. This is not fate. It is drift. Drift guided by accumulated interaction. The vacuum does not decide the future. It leans into it. This leaning is gentle enough to be mistaken for nothing. But nothing does not produce coherence. Coherence requires environment, and the vacuum is the deepest environment there is. This brings us to a threshold that feels almost unavoidable now. If the vacuum develops rhythms through accumulated interaction, then at some point, those rhythms may influence not just structure, but process. Not just where things form, but how they persist. Not just arrangement, but endurance. This is where the idea of influence becomes uncomfortable, because process is closer to what we associate with activity, and activity invites interpretation. But interpretation is a human habit, not a physical necessity. The vacuum does not act, it conditions. Conditioning is quieter than action, but more pervasive. It shapes outcomes without ever appearing to intervene. This leaves us suspended in a deeper question. If the vacuum carries rhythms shaped by complexity, and if those rhythms bias what can persist, then complexity may not be an anomaly. It may be a natural response to an environment increasingly shaped by persistence itself. Not inevitable, not guaranteed, but increasingly compatible. This thought does not conclude. It unsettles. Because once we accept that the environment itself evolves in response to what endures, the final boundary between background and participant dissolves completely. The vacuum is no longer merely carrying existence. It is being shaped by it, and that mutual shaping does not stop. It accumulates, which brings us quietly, inevitably, toward the final descent. Because if the vacuum can be shaped by accumulated interaction, then the deepest question is no longer about emptiness at all. It is about what happens when the environment of existence becomes inseparable from the existence it carries. That question waits just ahead, in the same silent medium that has been changing all along, unnoticed, while everything else unfolded within it. At some point, the distinction quietly collapses, not with a sound, not with an announcement, but with a slow erosion of certainty. We have been speaking as if there are two things, the vacuum and what exists within it, the medium and the structures it carries, the background and the events that unfold upon it. But this separation has been growing thinner with every step, because the more we look, the harder it becomes to say where the environment ends and where structure begins. In the physical world, separation is often an illusion created by scale. A wave appears distinct from the ocean until you follow it long enough. A storm seems like an event until you recognize it as a temporary configuration of air, heat, and pressure. Nothing stands apart from its medium. It only appears to. The same is true of the vacuum. We have treated it as a container, something that holds stars, galaxies, and time itself. But containers are passive. They do not change when what they hold changes. The vacuum does. And what changes with what it holds cannot remain a container. It becomes part of the process. This is the unsettling realization now pressing closer. The vacuum is not the stage on which the universe performs. It is woven into the performance. Every structure that exists is a configuration of the same underlying medium. Matter is not foreign to the vacuum. Energy is not injected into it from elsewhere. Everything is a modulation, a pattern of intensity, a concentration of interaction, a region where the medium behaves differently for a time. Stars are not objects added to space. They are places where the vacuum organizes itself into sustained fusion. Galaxies are not decorations scattered across emptiness. They are long-lived arrangements of matter, energy, and geometry within the same continuous fabric. Even particles are not separate from the medium they inhabit. They are excitations, localized expressions of something deeper. This becomes clear. The language of inside and outside begins to fail. Nothing is inside the vacuum. Nothing is outside it either. There is only variation. Variation in density. Variation in persistence. Variation in interaction. What we call structure is simply variation that lasts long enough to matter. And what we call emptiness is variation that does not stand out. This inversion strips emptiness of its final defense. Empty space is not the absence of structure. It is structure in its least concentrated form. This is difficult to accept because we are drawn to edges. We want to draw lines between things. We want to say, here is matter, there is space. Here is event, there is background. But the universe does not draw those lines. It blurs them. Blurring is not confusion. It is continuity. The vacuum provides that continuity. As complexity increases, the blurring deepens. Structures persist long enough to reshape local conditions. Local conditions influence future structures. The cycle tightens. At a certain point, it no longer makes sense to say that structures are merely occurring in the vacuum. They are part of how the vacuum behaves. This is not poetic license. It is the logical consequence of a system where environment and occupant co-evolve. When a forest grows, it becomes part of the climate. When oceans circulate, they become part of the atmosphere. When life persists, it becomes part of planetary chemistry. The vacuum is no different. Persistent complexity becomes part of its state, not added to it, not layered on top, integrated. This integration does not create awareness. It does not create intention, but it does dissolve neutrality. The vacuum is no longer a silent witness. It is an active context that has been shaped by everything that has endured. This makes the universe feel less like a collection of events and more like a single, continuous process. There are no clean boundaries between what happens and where it happens. There is only happening. This reframing changes how we understand causality. Causes do not act on a blank background. They act within a medium already shaped by prior causes. Effects do not vanish into nothingness. They alter the conditions of future interactions. Everything feeds forward, not dramatically, not deterministically, but continuously. The vacuum carries this continuity. It is the thread that connects eras without remembering them, which leads to a deeply uncomfortable idea. If the vacuum is inseparable from the process of existence, then the universe is never merely being observed. It is always self-interacting. Every part influences every other part, not directly, but through the shared medium that connects them. This does not mean instant influence. It does not mean signaling or communication. It means shared context. Shared context is more powerful than direct contact, because shared context shapes what interactions are possible in the first place. This is why distant regions of the universe can evolve in similar ways without coordination. They are immersed in the same kind of medium, governed by the same evolving conditions. Uniform rules do not produce uniform outcomes, but shared context produces recognizable patterns. This is why structure repeats. Spirals appear again and again. Filaments emerge across scales. Voids persist. These are not coincidences. They are expressions of a medium behaving consistently under varying conditions. The vacuum is not imposing these forms. It is allowing them. Allowance is subtle. It does not act. It does not resist. It does not direct. It simply defines what can persist. This makes the vacuum feel strangely intimate, not because it is aware, but because nothing exists without it. You cannot remove the vacuum from a thought experiment. You cannot imagine existence without it. Even in theoretical extremes, something remains, some background condition, some structure, some constraint. The idea of absolute nothingness collapses under scrutiny. There is always something, and that something behaves. This behavior is what we have been calling the vacuum. Once this is understood, the final comfort of emptiness disappears. There is no blankness beneath reality. There is only continuity. Continuity that has been shaped by everything that has ever happened. Continuity that shapes everything that will happen next. This does not make the universe purposeful. It makes it coherent. Coherence without intention is difficult for the human mind to accept. We look for meaning, for direction, for narrative. But the universe offers process instead. A process that does not end. This realization presses us toward the final question. If the vacuum is inseparable from existence, if it has been shaped by every structure that has endured, and if it continues to shape what can emerge, then the space between stars is no longer a backdrop. It is part of the story. Not a story with chapters, not a story with an author, but a story without edges. A continuous unfolding where medium and structure are indistinguishable aspects of the same reality. This brings us to the edge of the final descent, because once the vacuum is no longer empty, no longer passive, no longer separate, one last idea becomes impossible to ignore. If the universe is never without context, if nothing ever exists alone, if emptiness itself participates in existence, then perhaps the most unsettling thing is not that the vacuum observes or responds, it is that there has never been a place where nothing was happening at all. That thought does not close here. It hangs, suspended in the same silent continuity that has always carried the universe forward, waiting for the final question to be asked, not loudly, but quietly, as everything else has been. At the very end, nothing new is introduced. There is no final revelation, no hidden mechanism pulled into the light, no answer waiting patiently to be revealed. Because the universe does not conclude, it continues. And the space between stars, the thing we once called empty, continues with it. By now, the word empty no longer fits. It feels thin, inadequate, almost careless. What we have been circling around is not a void, but a presence so complete that it was mistaken for absence. Not because it hides, but because it does not announce itself. The vacuum does not interrupt existence. It sustains it. It does not stand behind reality like a background curtain. It moves with reality, reshaping itself as existence unfolds. Every interaction that has ever occurred has happened within it. Every structure that has ever endured has been supported by it. Every change has altered its state, however slightly. Nothing has ever bypassed it. This realization does not arrive with clarity. It arrives with quiet. Because once the vacuum is understood as inseparable from existence, there is nothing left to contrast it against. No other to define it by. There is only continuity. Continuity of interaction. Continuity of constraint. Continuity of influence. The universe is not a collection of things placed in space. It is a continuous process, expressing itself differently in different regions. Stars are bright expressions. Galaxies are long-lived expressions. Voids are quiet expressions. All are variations of the same underlying condition. The vacuum does not surround these things. It is the condition that allows variation at all. This is where language finally gives up. We cannot say that the vacuum acts. We cannot say that it observes. We cannot even say that it responds in the way we expect systems to respond. All of those words carry intention. The vacuum carries none, and yet it participates. Participation without intention is one of the hardest ideas to hold, because participation feels like involvement, and involvement feels like meaning. But physics does not grant meaning automatically. It grants consequence. Every interaction has consequence. Every configuration has effect. Every persistence reshapes the environment it persists within. This is enough. Meaning is not required. The vacuum does not need to know anything for reality to unfold the way it does. It only needs to exist as it does. This strips away the final temptation to anthropomorphize emptiness. There is no watcher in the dark, no awareness behind the fabric of space, no intelligence waiting quietly between galaxies. There is only a medium so fundamental that it becomes invisible. Invisible not because it is hidden, but because it is everywhere. The mistake was never thinking the vacuum was empty. The mistake was thinking emptiness meant nothing was happening. In truth, nothing has ever stopped happening. In the deepest voids, fields fluctuate, conditions persist, possibilities are constrained. The medium remains active in its quiet way. Activity does not require motion we can see. It requires only existence unfolding in time. This understanding does not offer comfort or fear. It offers perspective. The universe is not fragile. It does not depend on attention. It does not require observers to validate it. It unfolds because it unfolds. And the vacuum is not the absence beneath that unfolding. It is the continuity that makes unfolding possible. This is why the space between stars feels so vast, not because it is empty, but because it is uninterrupted, uninterrupted by edges, uninterrupted by boundaries, uninterrupted by silence, because silence itself is part of the medium. We look into the night sky and imagine distance as separation, but distance is only separation if there is nothing connecting. Here, there is always something, a continuous fabric of conditions, carrying light, shaping motion, guiding probability, and holding history without remembering it. Nothing stands alone, not stars, not galaxies, not even the voids between them. Everything exists within the same quiet continuity. This is not a revelation meant to be understood fully. It is a realization meant to be felt. Felt as a soft unease, felt as a dissolving of edges, felt as the sense that the universe has never had a true background, only presence. And presence does not need to announce itself. It simply remains. So when you imagine the space between stars now, do not picture emptiness. Picture continuity. A medium that has carried everything that has ever existed. A medium that is still carrying everything that exists now. A medium that will continue, quietly, long after structures fade. Nothing dramatic will happen there. And that is precisely the point. The most fundamental things do not need drama. They only need to endure. And as you let your thoughts drift, as the questions loosen their grip, there is one final idea worth letting pass without holding on to it too tightly. If there has never truly been an empty place in the universe, then perhaps what we call emptiness was never the absence of something at all. Perhaps it was simply the universe in its most patient form. Close your eyes now. The stars are still burning. The galaxies are still drifting. And the space between them, quiet, continuous, and unseen, is still there, doing exactly what it has always done, holding everything without ever asking to be noticed.